In this video, we will look into the writing part and we begin with the question 16 that is about continuity and limits. We have a problem here. Suppose that a state's income tax code states that the tax liability on X dirhams of taxable income is given over here. This is a piecewise equation. You can see there is one piece, two pieces, and three pieces. The first equation and the limits are given here. The condition is X must be less than or equal to 0. Whereas for the condition of the second equation here is X is greater than 0 or less than 10,000. And lastly, it is less than or equal to X is greater than or equal to 10,000. So these are the three conditions and these are the three equations here. Now we need to determine the constant C. The C value is unknown, which makes it continuous for all values of X. So now this must be all continuous. If this is continuous, then we must have the limits equal for all these conditions. Now, let me just quickly tell you about continuity. Now, imagine I have a graph like this. If I take any point, if this point is continuous, then the previous value and the right side value will match. They will be at the same point, isn't it? The y value over here will be exactly the same for both the points. It might vary by 0.00. Basically, when you equate that, only then it is continuous. Now, if we have, say, discontinuity like this, and this point do not match, the value over here and here, left and right do not match. So now, how we can solve this is, because since there is only one unknown, one variable, that is, one constant value C, I'll just consider this equation for sure, C plus 0.21x. But now, how can I solve this? When you consider this 10,000 value, you need to also consider the above equation. What is that? 0.14x. Now, they both are not equal, but if you take the limits at x, what is the x value? Of 10,000. See, it's 10,000. And over here, limit of this first equation, also x is at 10,000. This one, and over here, this one. Over here, I've written big brackets because there are 2 points, but you can just write the small brackets, it's fine. So these both are equal. These both equations aren't equal, but because they have told it is continuous, the function must be continuous for all x values, right? Then the limit of this and this will be equal. Which is the corresponding limit? If it's 10,000, 10,000. If you're taking equation 1 and 2, you should take limit x value of 0 and 0. Now let's solve this up. So all you do is substitute the limit over here. Let me just write it out over here, 0.14. What is the x value? It's 10,000 multiplied with 10,000. That is equal to, here C is unknown, but C is a constant. They have mentioned C is a constant. So what is the limit? Example, limit of x, say, tends to any value, okay, 0. Whereas you have over here 3. What will be the limit? It's going to be just 3 itself. Why? This constant value remains as it is. So in this case here, the same thing happens because it's a constant C. Doesn't matter what is the limit. When you apply the limit to the constant value, it remains C itself. Last, but here there is x term. So you substitute the x term, right? So 0.21, this is point. And now instead of x, what do you multiply it with? 10,000. So now you can just simplify this. Since it's the writing part, I'm not going to use calculators here. Let's just directly do it. It's 0.14. When you multiply it with 10,000, it'll be 1,400. So 2 decimal places. So just take 2 zeros and 2 zeros remain. And over here also it is C plus, it'll be 21,000. Sorry, 2,100 or 2,100. That's it. Now you need to find the C value. So what do you do is take this to the other side. It's going to be 1,400 minus 2,100. That will be C, or C value is negative 700. So that's the C value, the constant value. So this is what they are asked us to solve. Now that's it. C is negative 700. I hope you know the limits, you know the basics of it. If you are still having confusion with how this and all works, you need to go to the lesson explanation and be thorough with it. Now here I'll just stick to these questions only. Here they have asked you to give rationale why such a function should be continuous. This is very important, understanding why. Now, there are various ways. I'll tell you what this means. But before that, let's look over here. If the salaries are less than 0, so x is less than 0, so now we can ignore this. It's 0 tax, obviously. Now, if the salaries range from, say, 0 to 10,000, then your tax range is over here given over here. Then as your salary income is increased over here to, say, 10,000 or 10,000 or more, then this is the slab rate. Now imagine if they're not continuous. You earn 10,000, you will be taxed over here. But what if this is very high and then you are earning just little bit more than 10,000? Let us say 10,500 dirhams. So then if this was not continuous, that means this can be very high. Then there is an unevenness, right? This is going to be very high tax just for 10,500. That shouldn't be the case. If you're earning 10,500, it must be very, very close to this. So that is the reason they are all continuous. So, you just increase a little bit of income, it's not going to be a problem. As you increase more and more, that's going to vary a lot. Only as the salary increases by a lot. Maybe if it's 50,000, yes, this is going to change a lot. But if it's from 10 to 11,000, it's not going to change. See, over here they are telling a small change in income should not result in a big change in tax. Of course, because if you're just earning, say, from 10,000 to 11,000, you won't have a big change in the tax. That's the understanding behind it. Now let's solve another problem here. It is similar to what we have done just a while ago, but here you have two constants, two unknown constants. So we can't start with these two. See, we can't use these two over here. Why? Because there are two unknowns. If we take limits of this equal to this, your a and b unknown not gonna help us, right? So what we do is we'll take the equation 1 and equation 2. Let me write limit as x. What is the x value here? It's 0. Okay, now when I'm doing this problem, I just realized the inequalities, the signs must be given here. The last problem I did not mention this. I'm sorry for that. Now I'll mention it properly. Let me leave it for as x for a while. This is equal to limit as x tends to, again, it's, see, if we are taking 0 here, it must match. It's 0 itself. Now what is the limit here? A plus 0.12x. Now here, can you see it's less than or equal to? So let's take a negative sign. That means it's showing from the left side. Now here, it's again, x is greater than 0. So we can take a plus sign, means indicating it's from the more than that value. So this is the difference, because here x is less than or equal to 0. So negative sign, here it's positive because it's greater than 0. Now then, how would we solve this? Limit of 0, it's a constant, so 0 only remains. What about this? We have a plus 0.12x. You substitute 0 here, it will be limit of a. See, this limit is for a plus limit of this one. A is a constant, so it's a. But over here, what happens is, since we have x, we have to multiply x as 0, and we will get 0 is equal to a. This is again 0 plus 0. So basically a is 0. That's it. That's the first part. Now we will do the second part to solve for b, because now we found a. We know it's 0 here. Now we can easily solve it. I'll just clear this all up and let us do these two equations. But we know here the value of a is 0. Okay. But when I'm writing the limit equation, I'm going to take this directly as a itself, a plus 0.12x. What is the x value? It's not 0, it's 20,000. See, 20 and 20, we are going to use x value of 20,000 for both. It's 20,000. That will be equal to limit x value tends to, again, it's 20,000. And over here we have b plus 0.16, again, times x minus 20,000. So I'll use the big brackets here just for indication. And now where does it become plus and minus? Over here, the limit. Now since x is less than or equal to 20,000, over here it's minus, and over here it's greater than, so it's plus. If it was equal to, you can just leave it as x is 20,000 itself. Don't need to put any signs. This sign indicate it's more than 20,000 or greater than or equal to. This minus indicates it's less than or equal to. Now I know this a value is 0. So limit of a that is 0 is 0. Plus what about this limit? It's going to be 0.12 multiplied with 20,000. So that will be equal to right side. Limit of b, since it's a constant, it's b itself, plus 0.16 multiplied by 20,000 minus 20,000. So that's going to be 0 again. Now this is the thing. Anyways. So here I have 12 multiplied by 2, it's going to be 24, and 1, 2, it's going to be 2400 or 2400. Here we will have b as it is, plus this is going to be 20,000 minus 20,000, which is a 0 multiplied by, I'll just write it over here in detail. It's going to be 0, and now this is again going to be 0. B plus 0. Here we have 2400. So A value was 0 and B value is 2400. This is the answer, and A value was 0. So those are the two answers. We need to do the steps in detail. All this, if you write, you're going to get full marks in writing. So here you can see they have written the first one, A is 0, B is 2400, but just don't write the answer. There's no way you're going to get marks. This is for the second B value, but we did the similar way for A value. You need to write everything in detail. In this problem here, we have to continue from example 4.8. In the example 4.8, we basically solve the A value from this table. Now, these are the given values. You have the equations, and the remaining equations you need to solve by yourself. In the sense, it's just very simple. Your tax liability is given as 30%, which is say 0.3. In percent, 30% is 0.3 x minus this value a. So the next one will be 0.35 x minus b, and so on. Now what is the limit? Ranges over here is 67,700, where x, see, now the continuity is the same. X is less than or equal to, over here it is 141,250. Now, most likely this will be given to you in the question. Okay, now because it's continuing from 4.8, it's a little bit confusing. But otherwise, as you have seen the other problems, this will directly be given, and the constants also will be given in the question, and it will be pretty straightforward. Now, how do you solve this problem? Now, you need to use the last one over here, this one, and then this one, and then you can easily solve for A. And A is done. We have to deal with only B and C here. Now I'll write the equations for these. It's pretty simple. 0.35x minus b. So I'll just write it over here. We already have 0.3x minus a, which is over here given. Next one is 0.35x minus b, and lastly is 0.386 minus c. And these are the ranges over here given. I'm not going to write it again over here. But now, how do we solve it? A value is known, so let us take this and this. But what will be the x value limit? It will be 141 and 141 to solve for B, because A value is known. Now let me substitute over here with the limits. Let me write it over here. Limit as x tends to 141,250. This is left side because it will be less than. X is less than this value. And that's the first equation, that is 0.3x minus a. This must be equal to the limit at the right side, that is again 141,250, and this is from the right side because x will be greater than this value, and it is 0.35 x minus b. Now all you do is substitute the value of a over here. It is 5685. Now what happens here is it will be 0.3 multiplied by this x value, 141,250. That's the first part, minus a value. As we know, it's a constant value. Limit doesn't affect the constant values. It will be just 5685. 5685. And the right side here, the similar thing, it will be 0.35 multiplied with 141,250 minus b. See, this is the only constant. Now you can type this all entirely in the calculator and solve. Since the numbers are not whole numbers, we will use calculator to solve here. Now here, what I'll do is I will try to solve part by part because it's writing. So the first section here, 0.3 times 141 times 250, 141,250. Here you get it as 42,375. This will be subtracted from 5685. And here, the right side, all you do is, yeah, it's just 5 times, and when you press ST you get the value in decimal. It is 49,437.5. Now you might be thinking, can we directly put this in the calculator and get the answer? Absolutely yes. I'm sure you will get full marks even if you put directly this equation in the calculator and b as the variable x and shift and solve. You will get the answer. You can use that directly, but since it's writing, I'm just using steps. Now here, what happens is this is negative b. So we have to take this minus b to the other side and all the numbers to the right side. But before that, we can just simplify this, right? 42375 minus 5685. The answer is over here 36,690. So I'll directly take this negative b to the other side, becomes positive. And here we have 49,437.5. And this answer over here, 42 is bigger, so it's 36 is positive. But when it moves to the other side, it becomes 36,690. When you solve these two numbers, 42,000 so on and 5,600, when you subtract it, you're going to get 36,690 positive. But we move that to the other side of inequality and this negative b to the other side. So negative b will become positive b. Now all you do is, I'll just subtract it over here just to save time of typing. And the answer, it should not be negative because I use the other way around. The answer is 12,747.5. So B value is 12,747.5. That's the B. Now similarly, once you have found the B value, you can equate these two equations. And just like what we have done over here, just substituting this to phi x, and this x value changes to 307,050. And then over your right side, the equation changes. C will be the unknown variable, and just continue the same method. You will get the answers. So here you can see the value for B is solved. You can see the answers are over here. And let us just double check our answers. Did we get it all right? We got 12,747.5. Yes, that's absolutely correct. This is the B value. Now, similarly, when you solve for the C, whatever I did a while ago, see, the same thing, same method is very important. Only the equations change. You will get another answer, but that will be the C value. So here, the C value. Do it by yourself and then check the answer. It's 23,801.3. Again, we have to use the same example over here. Show that Tx is continuous for x is 6,000. Now, where is x equals to 6,000? That's over here and over here. There are two inequalities which vary, right? So we'll take these two equations and solve quickly. If it's continuous, when we solve these both, the x values must match. What I mean is, let me do limit x. I'm not going to write both together. I'm going to individually do it. Limit x tends to 6,000 from the negative side. It's 0.10x. Okay. I'll write it anyways equal to, but then I'll solve it individually. Must be equal to the limit as x tends to 6,000 from the right side. That's plus side. Okay. What is the equation? The equation is 0.15x minus 300. So these two must be equal. So now let me do it separately over your left side and then let's see whether it's equal to the right side. What I do is I just substitute this over here. 0.1 multiplied by 6,000. Here what happens? It's 0.15 multiplied by 6,000 minus, see this is the first part done, minus 300. Wherever x was there, I just put 6,000. That's it. Now here it's pretty simple. 1 0 is gone. It'll be 600. But now what about this? 6 5, it is gonna be 15 times 5, 75, 85, 90. So 90 and 1, it'll be 900. So this is 900 minus 300. And let's see, yes, 900 minus 300 is 600, and over here also is 600. Yes, these two limits of x tends to 600 from the negative side of this given function t of x is equal to the limit of x when it tends to 6000 from the positive side t of x. If this is true, then what, it is continuous. So yes, we can say 100% it is continuous. That is what happens. You are getting 6000 and 6000 in both the cases. So yes, it is continuous at 6000. Again, similar problems. It's just that we have a over here you can see there are different types of problem. There are about 3 types of problem. The first type is done. That was about tax problems, and now we have again similar continuity. It's the same concept. We will do this now, and then we have another type altogether in different page number which we'll solve. So now these, just like the first type, what we need to do is here see what is the x value. It's all 0, so it's easy. We need to find a and b. Because this is all known and this is unknown, we will use these two and then we will use these two. So how do we solve it? Left side, the limit as x tends to 0, it's less than, so it's minus 2 sine x by x. Please remember to put this minus sign. I tend to forget it. I many times may have forgotten in the video as well. I can't recall now, but you please don't forget to put this. You have to put, if it's less than, it's minus. If it's equal to, just leave it as limit. That's fine. Now here limit as x tends to 0, but what is the value? It's a. That's it. Now since it's writing, you can't use calculator, or if you just use calculator we'll get the limits directly, but now we will solve it. 2 is a constant, so it's done, but the limit will only be for this part. X tends to 0 from the left side, sine x by x, then equal to, what is the limit of a? Any constant, it will be the constant itself, so it's a itself. Now if you recall, do you remember the formula limit of x tends to 0? I'll write over here, there's a formula as it's 0 for sine x by x. The formula is given as 1. Please remember, you can do it in your calculator as well. We have done it before in the lesson explanations. Just remember, this is a formula. Now since it's writing, you need to write this somewhere and apply over here. It'll be 2 times this entire thing is 1, that is equal to 8. So 2 is a. Done. But now we are not done completely, because we have one more thing over here, right? So we need to do these 2 equations as well. Similarly, just like what we have done over here, we will do for the other 2. Now just remember, a value is 2. I'll clear this off and write it over here itself. So here now limit as x tends to 0. What is the, it's a, but we know a is 2. We'll write it in a while. Now x tends to 0 from the positive side because x is greater than 0, and here we have b cosine x. Now this is 2, so the constant remains, it's directly 2. But what about this? B limit as it is. Now because it's a constant, the limit will only be applied to wherever x is there, right? So x tends to 0 from the positive side, cosine x. Here what happens is basically substitute this 0 instead of x, because it's a polynomial, right? There's no divided by x. It's not going to be undefined. These are all straightforward substitutions. So when you apply 0 to x, cos 0 is 1, sine 0 is 0, cos 0 is 1. You can check it in the calculator. So here you just remember it is going to be 1, so 2 is equal to b. In fact, both the values a and b were 2 itself, so both are 2. So that's how we solve it. Please write these steps, they are very, very important. So both the values are 2. A and b must be equal to if f of x is continuous. Say if this is continuous, what we did is valid. The method which we did, this is important, and then you get the answers of the constants. Let's try one more Again, it's similar to what we have done just now. I would highly encourage you to stop watching this video now. Solve it by yourself. Pause it. Pause the video, do it by yourself, and then check for my explanation. I hope you have tried solving it by yourselves. Here we have entirely given is only this. There is a constant A, constant B. So we will use 1 and 2, and then we will use 2 and 3. So limit as x tends to 0, less than means minus a e power x plus 1 must be equal. Since there are two terms, I just put a bracket. Limit as x tends to 0 from the positive side. Why positive side? Because over here x is greater than 0. And what is it? Over here it is sine inverse of x by 2. That's the thing. And now what you do is you basically substitute the values. How do you substitute this? Direct substitution. There is no denominators over here. So direct substitution would be, first of all, let's say over here there is a variable a that will remain. And when you substitute e to the power 0, anything power 0 is how much? It's 1. You can try any number to the power 0, or you can write e and 0, it will be 1. So let me substitute this first and then let me solve it. And what happens with the constant? Again, over here there's no x, so 1 remains as it is. This side, it is sine inverse of x is 0 by 2. Now let's solve it up. Now what is sine inverse of 0? Sine inverse of 0 is 1, but let me just double check. My bad. Sine inverse of 0 is 0. But anyways, let's see how to do it. Shift and sine. You'll get sine inverse 0 by 2. And over here, close a bracket, you get 0. Now I feel so silly. I don't know. It just vanished from my mind, I guess, a while ago. Sine inverse is over here 0. Then over here what happens? E to the power 0 is 1, so a remains plus 1. Now this a to the other side becomes a equals minus 1. So the first answer is a is minus 1. Now we find this. In fact, we don't need to join these at all because they are completely different. So sine inverse remains here. All we do is the left side changes. So what I'm going to do is, instead of rewriting everything, the right side is same. So I'm just going to change this side. Okay. So that is me being very lazy not to rewrite anything. Oh, my limit is gone. Let me get it back. Okay, it's back. Now here what I do is the limit. Oh, I need to make it 2. That changes. Okay, the values change. But anyways, most of the other things remain. Here limit is 2 and 2. Now since I've written this at the right side, remember x is less than or equal to this is minus, this is greater than, it's plus. What is this? It's x squared minus x and plus b. So now we substitute this 2 instead of x, it'll be 2 squared minus 2 plus b. And here also instead of x we put 2, so it'll be sine inverse of 1. It'll be half pi or something. Yeah, half pi or pi I was thinking. Anyways, sine 2 by 2 is 1. Sine inverse of 1 is half pi. That is basically 90 degrees. Now let's write it in terms of half pi itself. What happens here? It's 2 squared is 4 minus 2. It will be again 2 plus b. 2 squared is 4 minus 2 is 2 plus b. And I'll take this to the other side. b is half pi minus 2. Let's leave it like this because generally if you leave it like this in terms of pi, it's more than enough. Let's see the solutions as well. What was the first answer we got? Yeah, I believe we got minus 1 itself. Yeah, I can't exactly remember, but the just now's answer is yes, half pi minus 2. So this is how we solve these problems. And now there are few more problems. Please do try it by yourselves. It's the same thing. Use calculator when you substitute. See tan inverse. Use calculator, natural logarithm. Use a calculator to verify your answers. And you can see the method is also over here. Try these by yourselves and check for the answers. And over here. Okay, we will go to the last type of problem here. 67th. These 67 to 71, there are, I think so, two different types of problems. Let's look into them. Suppose that the length of a small animal t days after birth is given over here. Length over here, the height as a function of time, 300 by 1 plus 9 of 0.8 power t mm. What is the length of the animal at birth? What is the eventual length of animal? That is the length as the time goes infinity. That's the maximum length of the animal. So now, many animals can be modeled by this equation. They take a lot of data from like various different many animals of the same species, and then they come up with these equations. These are more reliable. They give you, I mean, not more reliable. Sorry, they are reliable enough. They give you accurate enough data. So now, let's first understand what is happening. So they have an equation over here, and this will give you the height or the length of the animal at any time t. So at birth, what is the time? Time is 0 at birth. Generally this will be 0, but let's just substitute and solve. It must be 0. So now what is the time t at birth? 0. All you do is substitute over here, take the limit as t tends to 0. This will be 0 and we need to solve it. I'll solve it in a minute. But what about the other thing? T infinity means, imagine it, you don't know what's the time length, lifespan. It may be 10 years, 20 years, anything, right? So infinity means the maximum length it can reach, the maximum. So then we take limit, t is infinity, and we get it. Now let's solve one by one. First one, limit as x tends to 0 for this function 301 plus 9 of 0.8 times t. Let's just substitute this as let's just substitute directly t over here as 0. It will be 300 divided by 1 plus, see, whatever you substitute here, what's going to happen? It's going to be 0. So that's power 1. 0.8 power 0 is 1. So it's 1 plus 9. So you have 300 by 10, and this cancels, it's 30. Okay, I apologize. I told something wrong. I told it's going to be 0. My bad. At birth, animals have some sort of length. What am I thinking? You know, it's pretty late at the night, so that's why my brain is getting frozen, I guess. So this is the length mm. So when babies are born, there is, you know, some weight, minimum weight. You know, on average, it's 30 mm for this particular animal. Now, what if it's the maximum? X is infinity. So the same thing, you just take t as infinity and solve it up. Here time t, but this limit, okay, this is not x, I'm sorry, I just realized it. It's t. Now you substitute t as infinity here. It's 300, 1 plus, okay, I've not done the substitution over here. It's better you do one more step, just that t becomes 0. See, I'll show it over here. It's 9, 0.8 power infinity. Now, what's going to happen when 0.8 is infinity? Now, let's use our calculators and check here. Let's take a whole number. Let's take a number which is bigger than 1. Say 9 power, I'll take 5. See, it's increasing. Let me take 10. It's a huge number. How about we'll take 99? It's a huge number. It's going towards infinity, right? But now the same thing, I'll make it as 0.9. Can you see it's getting into a smaller number? See, here, always remember, when you have anything less than 1, say 0.1, when you take this, it's such a small number, it's 0.00001, it's almost equivalent to 0, okay? Now we have here 8. When you're taking a huge power, that is infinity is a huge number, you will get a bigger and bigger as the power increases, you get a minute number. So when it's infinity, it's 0. So you can see it's almost 0. If you put more values, I think so, yeah, it's 0. So here what happens is, this is going to be 300 divided by 1 plus 9 times 0. So it is 300 by 1, because this is 0, it's 300 mm. So the maximum length that will reach is 300 mm. The minimum is 30 mm. So these are the two answers. Please write this and this. That's it. Now here they have not written anything which is not desirable. Like, I mean, you can directly get the answer from here, but still it's better to write the steps. Okay. A similar question again, just the equations are changed. Now I would highly encourage you to do it by yourselves. I will just show you here. The steps would be limit as x tends to 0 and limit as x tends, it's not x, it's time, right? Time tends to infinity, here also time. And what is the equation? It is 100 divided by 2 plus 3 times 0.4t, and here it is 100 divided by 2 plus 3 times 0.4t. You substitute here 100 divided by 2 plus 3 or 0.4, this power is 0. But here what happens? It is 100 divided by 2 plus 3 into 0.4 infinity. And when it's 0, it's 1. So it will be 100 divided by 2 plus 3 only, because this is 1. And it's 100 by 5, 20 times 220. And over here we have, it is 100 divided by 2 plus, what happens here? It's 3 infinity 0.4, so it's 0. 3 multiplied by 0 here. So it's basically 100 by 2, that is 50. Now it's in terms of mm. That's it. That's how we solve these problems. 20 and 50 is the answer. So maximum length is 50, minimum is 20. Okay, this is different. Let's solve this one. Suppose an object with an initial velocity v0, v0 is 0 feet per second, and a constant mass m, slugs is accelerated by a constant force f pounds for t seconds. According to Newton's law of motion, the object speed will be velocity n given as ft divided by m. See, this is Newton's formula. Velocity of n, that is n is for Newton, is force times time. Force times, in this sense, multiplied. Force multiplied by time divided by mass. And then Albert Einstein does this theory of relativity, and he got this new formula, which is more reliable because this was wrong. You might have studied in physics. What happens? What is the flaw in this? The flaw is the velocity is supposed to be infinite. As the mass becomes 0, I mean, when you take the time infinite over here, infinity, what happens? Mass is becoming almost equal to 0, right? So this velocity also becomes infinite, which is really not the case. What is the maximum velocity we can ever reach according to the laws of physics? It is the speed of light, isn't it? So Albert Einstein added the speed of light here. Now let's see Albert Einstein's. It's a little bit more complicated, where c is obviously the speed of light divided by the square root of mass squared c squared plus f squared t squared. Okay, now what do we do? All we do is take the limits at infinity. Time t is infinity. It's pretty straightforward. So we have to take the limit of this function only. This is velocity given by Newton. Time tends to infinity. And what is it? Function of time divided by m. And here when we substitute this as infinity, what happens? If infinity is on the numerator, everything is infinity, right? That's the answer for velocity for Newton, which is wrong. Why? Because we cannot go past speed of light. Let me just tell you, this is very interesting concept. Speed of light is about 300 million meters per second, or it's 300,000 kilometers per second. This is a very enormous speed because no one could define this before. Obviously, Newton was in a very many centuries before Einstein, so he didn't have a lot of technology, but he still found a lot of things. But Einstein rectified a lot of things as well. Now he found out from the speed of light is the maximum we can travel. But in our real world, we have just reached about, I think so, 2,500 kilometers per second. This is the maximum speed we have ever achieved. in the whole world. Now the speed of light is 300,000 kilometers, and we have barely touched 2,500. I think so. It's less than 2,500. So this is the difference you can see. So there's a huge, huge, huge difference. Okay, it's very not comparable. But anyways, coming back to the question here, velocity of E, that is Einstein's velocity. Now same thing, we do limit as x tends to infinity, and here what happens is basically, okay, first let me write it. FCT divided by square root m square c square plus f square t square. Now put infinity wherever. But before that, since we have t over here and t, what do we do is we have to remove this out and try to cancel or simplify as much as possible. Don't directly put infinity. That would be wrong substitution. Why? Because there's up and down here, right? We have to simplify this term. So t, let it be fct. But down, you remove this t outside, but there is no t, so you divide, multiply and divide over here, and then you will have two common t's. So it'll be t square out t. When you take outside the square root, how much is it? It's just t. So basically, in such cases, you remove this outside, it's just t square root m square c square. Was there any t square here? Only t square was over here, which we removed, it became t. So there was nothing here, so you basically divided by t square plus f square only. Why here f square only? Because you can see this t square is removed outside and it becomes t. Here you divide it. That's a simple algebra over there. And now this cancels off with this, so you're remaining with fc divided by square root m square c square by t square plus f square, and the limit is what? As x tends to infinity. Now this t becomes infinity square. 1 by infinity is equal to what? 1 divided by huge number is equal to 0. Limit of whenever we have limit 1 by x, when it's tending to infinity, it's 0. So this entire thing, mc square, everything becomes 0. Now we are remaining with fc by square root f square, isn't it? Now this cancels. You have fc by ff cancels c. That is the speed of light. So according to Albert Einstein's velocity over here equation, the maximum velocity you can ever attain is the speed of light. This is the answer. I just googled it. I don't know how this was sticking to my mind. It is really 40,000 kilometers per hour. That is the maximum speed humans have ever achieved. I think so. It's an Apollo mission. I just googled this, but this is in hours. But when you convert it to kilometers per second, this is going to shock you. It's just 11.11 kilometer per second. So the speed of light is 300,000, whereas in the universe we have, in Earth we have just reached 11.11. You can see the difference, it's 11.11 and the speed of light is 300,000, but this is the maximum we can ever attain. But it's kind of very, very such a huge number to reach. Anyways, we will move on to the next question here, and you can see this is the answer. For the first one was infinite, yes, and second one is just C. Here we have a question about medicine. After an injection, the concentration of the medicine in the muscle varies according to the function of time. So the concentration, once after you have been injected, varies according to the time, and it's given by this function over here. Find the limit f of t for both as t is 0 and infinity. So we should do the limit of 0 and infinite, and interpret both limits in terms of concentration of the drug. Now let's solve it up. Limit as x tends to, sorry, it's not x, it's again time t0 for this given function, minus 0.02t minus e to the power minus 0.42t. Now since it's 0, I can just directly substitute. Otherwise, if it's infinity, what do you do is you have to take it down because it's minus, right? I'll write that in a while. Let's just solve this for now. So all you do is substitute t as 0. So it's going to be e. Everything becomes 0 here. minus, we are e to the power 0. So e to the power 0 is 1 minus 1. So answer is 0. That's it. So that is when the time is 0. What about the limit as time tends to infinity for this particular equation? E minus 0.02t minus e to the power minus 0.42t. So what you basically have to do is, since there's a negative sign, let's write the limit as it is. I'm not going to substitute now infinity. I will take this down. E1 by e to the power positive 0.02t minus 1 by e to the power 0.42t. Now let's substitute the limits. It'll be 1 divided by e to the power 0.02 multiplied by infinity minus 1 divided by e to the power 0.42 multiplied by infinity. Okay, that's so far fine. Now what is e to the power infinity? Now e to the power infinity, since e value is bigger than 1, it's 2.72 and so on, right? You will get infinity here. 0.2 multiplied by infinity is infinity itself, and this is going to be infinity. So it's going to be 1 divided by infinity minus 1 by infinity. So 1 divided by infinity limit, it will be 0 minus 0. So answer is 0. So both the cases, the answer is 0 itself. So that's the answer, guys. Okay, this makes sense because drug will require some time to. Now it's about, you've been injected. Okay, when you have an injection, at the time 0 itself, you're not going to feel the effect. You might feel after some time, because since we're doing time 0, at that particular time 0, you won't have any effect of the concentration of the drug, right? So therefore, the muscles will be fine. It'll be just like normal. So there's no effect over here. And also, if you're taking t as infinity, it's going to be a long time. Obviously, the drug's effects will be gone off, But if you have certain, say over here, t is 1 hour or something, then you will have some value. But not in this case, because we are doing at 0, limit 0 and infinity. Obviously, the muscles will not have enough time to reach, or it will be wearing off. The effects will be gone. We move to the last question in this topic 16. That's question 71. Ignoring air resistance, the maximum height reached by a rocket launched with the initial velocity v0 is given over here, where r is the radius of the Earth. In this exercise, we interpret this as a function of v velocity, initial velocity. Explain why the domain of this function must be restricted to v0 is greater than or equal to 0. So here, obviously, v0 is initial velocity and it must be bigger than 0 because you're propelling a rocket, right? So depends on the direction. Rocket, it's flying up, so it's being launched with initial velocity to go upwards. So velocity must be positive. It can't be negative. It won't go down, So that's the reason. That's the explanation. Let me just look into the answer because I don't know how exactly they have written the answer. Yeah, that's it. Because the formula makes sense if the rocket is launched upwards. That's the only thing over here. Let's see the other parts. There is an additional restriction. Find the positive value of VE such that H is undefined. So we are find when H is undefined. Sketch the possible graph of H for V0 is less than V but greater than 0, and discuss the significance of the vertical asymptote at VE, that is V is the escape velocity. Okay, so basically we need to deal with when H is undefined, when this down term becomes 0. Okay, then this is undefined, right? When is any number undefined? When you have 1 divided by 0, this is undefined form, isn't it? So now here the numerator doesn't matter, the denominator when it's 0, right? So that is the vertical asymptote as well. So let's solve this one by one. Now we don't have to take any limits here, nothing limits. So the first one I just told you, since it's going upwards, the domain will be positive. What about this H? So let's just equate this entire term, 19.6 R minus V0 square. Okay, this will be equal to what? 0. Let's solve it up. Now what is the R? R is the radius of the Earth. So that is like 6,000 plus. I'm really not sure. Yeah, it's 6,000. Oh, it's given in meters. In kilometers, it's about 6,370. I was thinking it's 6,378 this 1,000 kilometers. Or over here, since it's given in meter per second, let's write it as it is. R equals 6,378,000. So that's the thing. Sorry for that. Now here, let me just substitute the values. Here, let's take this V naught to the other side. It'll be 19.6 multiplied by R is 6378000 equals V naught square. And let's take the square root on both the sides. And let's see what is the V naught value. Sorry, this one is the VE, because when H is undefined, it's VE. So it's the escape velocity. Let's use a calculators first. So all you do is put this in the calculator directly and you get this as 11,180. So basically this is the maximum, see VE is the escape velocity, right? Now what happens is when you launch a rocket, because of gravity, it's going to fall down eventually. But if you launch it with more than 11,180.73 kilometers per meters per second, then it's not going to fall back. So what happens is basically it's gonna go up and it's gonna go into the orbit. You know, it's not it'll not be affected by the gravity as long as it's more than the escape velocity. So that's the concept behind it. So we find the escape velocity because they have already told h must be undefined. So this denominator just equated to 0 and solve it up. So that's the answer. So you can see they've just rounded off. It's over here 11,180. That's the answer. So that would be the end, and the graph over here. So if you graph this up, you can graph it over here. When you reach 11,000, that's going to go up. That's the vertical asymptote. So what happens here? That'll be the maximum. So you can't reach more than that. So basically, that is the end of question 16. There were plenty types of problem. Make sure you try to write each and every question and practice by yourselves. In this video, we will solve question 17, which is to find derivatives using limits. You can see here, they have asked you to find the derivative using limits. These are the two formulas, 2.1 and 2.2, which are shown over here. F dash of A using limits. They're not the same. Now this one is a limit formula. Both are for derivatives, but now the second one, you might closely remember the slope formula. It's y2 minus y1 divided by x2 minus x1. It's similar to that. Over here, it's similar to that, but this height h is the distance between these 2 points, and the distance we are considering it to be 0. That's practically the same point, isn't it? Now here, if you look carefully, it's the same thing. B minus, when we take the limit over here, it's becomes 0, right? Almost, it's the same point itself. We are coming very, very close towards the same point from both the sides and finding the limit. Now we will solve a problem. You'll understand. This is the given function. A value is given. So first you need to write the formula. I'll write in detail for the first problem. We have to do for both these formulas. First, let's write the formula here. Limit as h tends to 0, and this is always a plus h minus f of a divided by h. Now you might be wondering, I've seen this formula in terms of x. Absolutely, that is also fine. A is equal to x here. You can also see it as f of x plus h, f of x by h. That's also fine, because here they have mentioned the a value or the x value. You can consider this as x or a value. Now what we do over here is we substitute first the a value, whatever is given. Now here, derivative of this, f derivative of 1, because they have mentioned to solve at 1, is limit as the distance h is tending towards 0. We have over here 1 plus h minus f of a. Now what is a? It's again 1 divided by h. Now how do we remove this h? This will be gone when we put the limit, but we can't apply the limit now because h0 will be undefined. Now here we have f of x. So let us understand this part. If we have f of x, what is f of h here? Instead of x, we have to just put h, right? That is the answer. Now, what about other terms? Let's say f of 1. Instead of x, what do I put? 1. That is the answer, right? But since it's all numbers, we can solve it. It'll be 3 plus 1, it's 4. Now, what about here? What do they want? A plus h is simplified to 1 plus h. What about f of 1 plus h? See, f of 1 we have already got, it's 4. But what about f of 1 plus h? Now here, instead of, when it was f of h, instead of x we put h. But now we have to put this entire thing instead of x. It will be 3 into x is 1 plus h. See, here we have 1 plus h. So we just substitute over here. Then remaining plus 1. This is it. Now if you simplify this, we can simplify it further, but let's substitute it in the formula and then let's solve it. Let's continue here. We have got the limit as the h tends to 0. Now what is f of h? It is 3 times 1 plus h plus 1 minus, what is f of 1? It's 4 and divided by h itself. So now here we have still this unknown variable where we have to take its limit of 0, but we can't do it yet. Why? Because we need to simplify whatever is up above. So let's simplify this. It'll be again limit as it tends to 0. 3 times 1 will be 3, and 3 times h is 3h, plus this 1 is separate. See, now this distributive property is done. 3 plus 3h. And over here we have 1 minus 4. I'll directly write it. 1 minus 4 will be minus 3. Here we did the distributive property. It's minus 3. Now this divided by h as it is. Can we solve this up? Yes, we can solve. 3 and minus 3 will be 0. So it will be limit as h tends to 0. 3 and 3 is gone. We have 3h by h, and this cancels. What is remaining? It's 3. Now if you take the limit, it's just going to be 3 itself, isn't it? So the answer over here is 3 because this variables are cancelled off. H and h cancels off up and down. So you're remaining with 3, and that is the answer. So f derivative of 1 is 3. So all this to find this. Since it's writing, these steps are very, very important. Now this is for the first one using this formula only. Now we have to do the second formula as well. I hope this is clear. Now you can always verify your answers using your calculator. I'll show you how. In your calculator, you can directly find derivatives by pressing shift and this symbol here. This is integral, but when you press shift and this, you get dy by dx, that's derivative. Now here you have to put 3 alpha x plus 1, and over here x value is 1, and see the answer is 3. So yes, that's the correct answer. It's just verification, but these methods are very, very crucial. Now let's use the second formula over here. So the same concept continues, but it's just that the formula is different, but similar way to solve it up. First, we need to write the formula f derivative of a, limit as b tends to a, f of b minus f of a divided by b minus a. Now what you do over here is, see, there is no complications like a plus h. You don't have to, write it. It's very simple. The same thing we write over here. See, for limit b tends to a, the numerator for f of b, it's just that instead of x we put b plus 1. That's it. For a, what we do, instead of x we put a. But what is the value of a? We know value of a is 1, right? So we can directly take it as 1. It will be 3 times 1 plus 1, that's 4. So we can directly use this. So f of b would be 3b plus 1. Then what do we have? Minus, what is f of a? F of a is 1. So I'll directly take this as 4. Because given over here as 1, so f of 1 is basically 4. divided by b minus, what is a? It's 1. Now let's simplify here. So you have, let me just write it over here, limit b tends to a, it's 3b minus 4 plus 1 will be negative 3 divided by b minus 1. Now here you can see 3 and 3 is common terms. We can remove it outside. So limit as b tends to a, 3 is taken out. What is remaining? 3 minus 1 from distributive property. Now if you multiply this back here, 3 times b is 3b, 3 times minus 1 is minus 3. So it's balanced. What do we have here? Minus b minus 1. So it's numerator and denominator having the same terms. We cancel it off. And limit of b tends to a for 3. It's a constant. Limit of any constant is just the number itself. So answer is 3. Yes, that's correct. So this is how we solve it. Now, if I had a choice, if it was over here or to choose which one, this or this, I would personally go with this formula. I mean, it's just the same. Even this is easy, but for I just would go with this because I find this to be easier and simpler for some reason. So that's how we solve these problems, guys. The answer is 3 and 3 in both the cases. Similarly, we can solve the other problems. I'll quickly try to solve this one. Now, I'm not going to write the formula again. It's over here. You need to write it in your exams. I'll do for both of these. So first one, f of, here a value is again 1 plus h will be 3 into, now instead of x, we have 1 plus h squared plus 1. And now, do you remember 1 plus h the whole square? This is like a plus b the whole square formula. This is given as a squared plus 2 times ab plus b squared. So we are going to use this identity over here. Now here what happens is 3, instead of a we have 1, it'll be 1 squared plus 2 times, 1 times h is 2h plus h squared plus 1. And now I will simplify this. It'll be 3 times 1 squared is 1 plus 2h plus h squared plus 1. And over here 3 times, we just multiply this inside as distributive property. We will get 3 plus 2 times 3 times 2 is 6h plus 3h squared plus 1. And over here finally I'll write the highest degree first, h, that is 3h power 2 plus 6h, and last I'll write the number that is 4. 3 plus 1 is 4. So this is basically f of 1 plus h. So what happens is we substitute this 1 plus h instead of x, but there it is squared, so this entire thing gets squared, and then we remove the square by using the identity of sum of whole square, Then what happens is we use the identity and simplify. We got this. Then one more thing is required. What is that? F of a value is 1, so we need also f of 1 here, and that will be 3 into 1 squared plus 1. This is easy. It's 1 squared is 1 itself, so 3 plus 1, it's again 4. And these are the two values. Now we will substitute it directly in the formula as, it's h tends to 0. It's a derivative of 1 over here because a value is 1. Now this first part becomes 3h squared plus 6h plus 4 minus, what is the second part? F of a is f of 1. It's again 4 itself, divided by h. This cancels. So now here, what is remaining? We are remaining with limit as h tends to 0. We have 3h squared plus 6h divided by h. Now we can remove h common because there is h and h, or you can divide this individually, It's up to you. I would personally remove the common term using distributive property. If you remove it outside, it will be 3h only because 1 is gone. And over here, this h is gone. You're remaining with 6 and denominator. And now you can cancel it. Or I will write another alternative. So then over here, what happens is this cancels off. You're remaining with limit h value tends to 0. You have 3h plus 6. So if you substitute the limit now, h becomes 0. So let's apply the limit. What basically happens is it'll be 3 times 0 plus 6. The answer is 6 here. That's it. That is the answer. Now, if you want, we will quickly derive this and check the answer. When we derive 2 comes down, it will be 6x plus 0. And substitute x as 1, answer will be 6 itself. Yes, absolutely, it's correct. So this is 6 times 1. But don't do that derivative because over here they have clearly mentioned to do it in limits. Now, over here, if you're getting confused with the distributive property, but the distributive property method is very crucial. You have to know that. But you can do one thing. What you can do is, see, from this step, I'll just write it over here. You can divide h individually for both the terms. And this cancels, this and this cancels. So you're remaining with 3h plus 6. Okay, so it'll be the same. Instead of this step, we do this and then this will be the same. So then we can continue. You write limits and continue. So this is using the first formula. What about the second formula? Now I hope this is clear. Let's quickly do the second formula now. Here, I'm just going to write these f of b here and f of 1 because 1 is a will be 1. It will be 3b squared plus 1. And over here we have 3 times 1. We just now did it plus 1 equals 4. Now you realize in this case, let's substitute over here 3b squared plus 1 minus 4 divided by b minus 1. Because we have been given a as 1, we directly substitute a as 1. Now then, how do we solve this? It will be 3b squared. 4 minus 4 plus 1 will be plus, minus 3, not plus 3, minus 3 divided by b minus 1. Now let's remove this common term. We have to write this limit all the time. Okay, in the exam it's very crucial. Limit b tends to a. And here what we do is limit b tends to a. Remove this 3 common out. Distributive property. See, here we have to do distributive property. There's no other way. And you will have b squared minus 1. And over here, denominator, we have b minus 1. Now, don't think, oh, we can just cancel it. No, it's not possible to cancel it directly. Why? Because this is b squared minus 1. This is just b minus 1. We need to split this using the identity a squared minus 1, a squared minus b squared. If you remember, it is a plus b, a minus b. This is the rule. A squared minus b squared is given. This is the difference of squares. Squared and minus, it will be a plus b, a minus b. There is no identity if there is plus. Don't think it's the same. No, there is no identity. Only when a squared minus b squared. Now we have, instead of a, we have b squared minus 1 can be written as 1 squared. So what happens here is limit as b tends to a, 3, and over here we will have b plus 1, b minus 1 divided by b minus 1. Now you can cancel these two terms. And you're remaining with, over here, limit as x tends to a, you're having 3 into b plus 1 only. Now we will, okay, I forgot to change one important thing. Sorry guys. What is a value? It's 1, right? Let it be. It's fine if you write it as a. But remember here, I will just change it from a, from this a value to 1. Why? Because they have told us in the question a is equal to 1. Okay, I changed over here, but I forgot to change it in the limits. You can change it everywhere over here after the formula. So now over here, what I do is I just substitute the limit. It will be 3 into, what is this, b, okay, it's b, not x. Sorry, I'm clumsy a bit. Please understand, these are silly mistakes, but please don't do them in the exam. You have to be thorough. It's b over here everywhere. The second formula is about b. First is about h. In the first one, it's 0, but over here, whatever the a value is given, we take it to that. Now we substitute over here. B will become 1, that is a value, plus 1. This is basically 3 times 2, that is 6, and that's the answer. Over here, we just now did 6 is the answer. Doesn't matter which formula we use, the answer will be the same. That is 6 itself. A quick reminder, I will be solving many problems, as many as possible in writing. But once you have understood, please solve them by yourselves and you can move forward by at your own pace. Now we will look into this problem. Here we have square root. Same thing, we will use both the formulas and solve. First one over here will have a plus h, but a is given as 1. So it's 1 plus h. Over here we will get x is 1 plus h plus 1. And that's it. So let's try to simplify this here itself. It will be square root 3 plus 3h plus 1. And that will make it, I'll write 3h first and then we have plus 4. Okay. And what about other thing? If it's 1, f of 1 will be equal to 3 times 1 plus 1. That is equal to 3 plus 1. That is square root of 4. That is 2. You can use calculator directly, but anyways. Now then, what do we do is, we use this formula. First, you need to write the formula because it's already there. I'm not going to write it every time. I'll directly substitute. F dash of 1 will be, this f dash is prime, okay? But I just call it dash. F prime means derivative. F prime of 1, limit as h tends to 0. Here, I'm not going to write anything away. Directly, I'll write this part. So it is 3h plus 4 because we already solved it up, right? And then minus, what is f of 1? This over here, 2, directly 2, divided by h. Now here, see, we have to take the limit of h as 0. Whenever we have denominator h, we cannot solve it. It will be wrong. Here, there is an issue. We cancel off this h with the numerator, right? But it's inside the square root. If it's inside the square root, there is no way we can simplify it further. So we need to do a manipulation called conjugates. You have to multiply and divide by conjugate. You know, what does conjugate mean? Now, when you have radical, that is square root, I'll take example of simple one, x, and then you have plus a, imagine, and over here x. You have to multiply and divide by the opposite sign of this. See, square root x minus a, and divide square root x plus minus a itself. Now what happens is, this is equivalent to 1. This cancels off and it's 1. So it's basically multiplying this term by 1. It's nothing wrong because we can multiply by 1 and this remains the same. So we are balancing it out. This is already 1, so it's balanced. Now here, what does it look like? The first term, it's a plus b, imagine like this, and a minus b. Look carefully. This is a, same terms, plus and minus, and there is bb, second terms. So the formula is a squared minus b squared, isn't it? We have used it in the last problem. Now we apply it over here. So what happens is x, root x the whole square minus a the whole square. And this square root and this cancels off, so you will have in the numerator x minus a square. Here down in the denominator, it's just that we multiply these both. So here both the cases, it will be just x multiplied by square root x minus a. Okay. Up, what happens is we use this identity. So let's use the same thing over here in this given problem. I use this simple example just to show, because it was single variables. Now let us solve it up. The limit as h tends to 0, square root 3h plus 4, the square root is for entire thing, minus 2 here, divided by h, multiply with what? Square root 3h plus 4. There is 2, but since we have minus here, we have to take the opposite sign. One should be plus and one should be minus. Minus is already there, we take plus. The same things, 3h plus 4 plus 2. Now here at above, this entire thing is like a minus b, a plus b. So we have to just square it up. Now, in your exam, instead of writing many steps, I will simplify this into a single step. Look here. This square root just cancels off because you're squaring it anyways. So I'll directly write 3h plus 4 minus, what about 2 times 2 square? 2 square is 4. So this happens. The first term, whichever has a radical, just write it without radical, minus the second term, just square it. Obviously, it must be the same terms, right? Now, down below here, h multiplied by root of 3h plus 4 plus 2. Now, this is all multiplied with h. Now, here, remember, we don't mind if h is in the denominator inside a radical with plus or minus. When you have other term, it's not going to be undefined. Now if you remove this term, then what happens is this h doesn't make any problems. Why? Because when you apply the limit of 0, this term is 0, but there is 4, so it doesn't make any problem, you know. So now what we do is we simplify the numerator here. Limit as h tends to 0. Here we have 3h plus 4 minus 4 just cancels off. It'll be just 3h. H divided multiplied by radical 3h plus 4, and then we have plus 2. Now here this cancels with this, so what remains over here is h tends to 0. We have only 3 in the numerator. Down we have 3h plus 4 plus 2 outside the radical. Now let's apply the limit. Limit h is 0, so it will be 3 divided by square root 3 times 0 plus 4, and then over here we have plus 2. And now if you put this entirely in the calculator, you can get the answer. Over here what's going to happen is 3. This 3 times 0 is 0, so it's 4. Radical 4 is 2. So it's basically 3. 2 plus 2, it's 3/4. So it's 3 by 4. That's the answer. Now you can use the derivative rules, square root rule. What is it? 1 by 2 root x. And you can simplify this and apply a value, x value as 1 and solve it. Or use your calculator directly and solve it. Your answer will be 3/4. Okay, this is using the first formula. Now I'll use the second formula here. So here we go. F of b will be equal to what? It'll be 3b plus 1. Oh, that's it. This is easy. Okay, the second formula is easy. I like the second formula more because you don't have that plus h and all the simplification. And over here we get 3 times 1 plus 1. Basically it's 4. 3 plus 1 is 4. Square radical 4 is again 2. This is the same thing like the previous one, only you don't need to write this again because when you're solving it for both, already it will be written once. Now what we do is, we will apply this formula. I'm directly going to substitute over here. Limit b tends to, what is a value? It's given as 1. Now here in the numerator, f of b is square root 3b plus 1. What about the next one? Minus, what about f of a? We know it's 2. Divided by, now b value is as it is minus 1. Now when you apply the limit over here, if you directly apply now, it's going to be 1 minus 1, 0. It's undefined. You can't do that. So we need to do the same conjugate method. Both the steps, both the formulas, we have the same concept here. But it's just that the values change. Over there it was 3h. Here we have 3b. So here we get 3b plus 1 minus 2 divided by b minus 1. Multiply and divide by the conjugate, that is 3b plus 1 plus 2 divided by square root 3b plus 1 plus 2. Here directly I'm going to write it b tends to 1. In the numerator we will have 3b plus 1 minus 2 square will be 4. This radical cancels off because the formula is a plus b the wholes, a plus b, a minus b is a square minus b square. Just remember that. Now in the denominator we have b minus 1. Okay, but what next? Here we have this entire thing, 3b plus 1, which is inside the radical, plus 2. So this is another term altogether. It's multiplied to b minus 1. Now let's simplify here. We have 3b minus 3. Denominator is b minus 1. And radical 3b plus 1. Sorry, now 3b plus 1 is all under radical plus 2. This is all multiplied. And the limit as b tends to 1. Even now you can't apply the limit of 1. Why? Because it's undefined. 1 minus 1 is 0. In the denominator we cannot have 0. But look over here in the numerator. We have 3b minus 3, which can be, we have done this before, 3 can be removed out, distributive property, and you're remaining with b minus 1, isn't it? Now down we have again b minus 1. Now we can cancel those terms. So let me do it over here. 3 into b minus 1. I'm removing 3 outside, distributive property. Limit as b tends to 1. Here we have b minus 1, and then we have square root 3b plus 1 plus 2. Now what do we do? This cancels and you're remaining with 3 divided by root of 3b plus 1 plus 2. Now it's fine to apply the limit. Why? Because limit is 1. If you apply here, nothing is going to be a problem because this is cancelled off. It's not going to be undefined anymore. I'll apply the limit. Numerator is 3. Denominator over here, we will have 3 times 1. Don't put 0. In the first formula here, it's 0. Here, it's a value and a given is 1 plus 1, and over here we have plus 2. You can just put this in the calculator, but I know it's going to be 3 by 4. Let's solve it up. It's going to be 3 times 1 is 3 plus 1 is 4. Square root of 4 is 2. So it's again 2 plus 2, and we have 3 by 4th. So that is the answer. So it's 3/4 and 3/4. Both the answers must be same because we are deriving the same function, but it's just two different formulas which will give you the same answer. So you can see it's 3/4 over here and 3/4 here as well. So that's how we solve this. And last one, okay, this is also different, so I'll solve this one as well. Here in 1 to 4 we use both the formulas, okay, this and this. So now again, let's quickly do it up. The first one is a, but now here look, a is not 1, it's 2 plus h now. So what's gonna be? It's gonna be 2 plus h plus 1. We will simplify this. It's gonna be 3 divided by h plus 3. Okay, why? Because h plus 1, 2 and 1 will be 3. Next is we have f of 2. It's not f of 1 anymore because a value is 2. So this is gonna be f of 2. So that will be 3 divided by 2 plus 1. That is 3 divided by 3, it's 1. So these are the two terms which we require. Now I'll use the formula limit as h tends to 0. And the function over here, the first one will be directly, I'm going to write 3 divided by h plus 3 minus 1 divided by the whole thing divided by h. Now how would we solve this up? Here we need to find the common denominator. This is like rational functions, right? Yeah, up and down, and there's a single term. So the concept is very simple. Let me just show you here. Whenever this is 1, you can't just do 3 minus 1. No, because the denominator is also 1 here. There is no denominator, that means it's 1. And here we have denominator. So basically, whatever is up over here, you need to multiply h plus 3 and divide to this h plus 3. Look, we are balancing it because this h plus 3 up and down, it's the same thing, right? It's 1. So we have not we are just manipulated. It's nothing wrong. It's balanced. We have just manipulated it. So now here what happens is we will have the left side same. Denominator is same. Minus, now right side it's going to be h plus 3 divided by h plus 3. So now when the denominators are same, easily merge them up together. So this limit as it's not h, I'm sorry. Okay, yeah, this is the first formula. Yeah, h. I thought we were doing the second one. Anyways, so we can write this denominators both as h plus 3 together, and up it is just 3 minus this entire term h plus 3, and entire thing divided by h. It's a bit lengthy, but now this is how we do it. Now what? Here we have to write limit as h tends to 0. Let me just go back over here. When we have limit as h tends to 0. We cannot apply the 0. Why? Because we have this h and it will be undefined. Now this denominator, see, let me write it like this. A by b divided by c. What exactly this means is this and this are together. This is equal to a by bc. Okay. Now if we had another term like d over here, then this will go up. It will be ad by bc. So this is the concept. Now here, since we have just these three terms, we can merge b and we can multiply b and c together, because that's the rule. When you have a divided by b divided by something else, this a is divided by b and divided by c. So these both can be written like this. So I'll write it the same way. Now 3 minus h minus 3 minus h minus 3 divided by h plus 3. And what do we have over here? We can write this h over here or over here. It's the same thing over here. And now this plus 3 minus 3 cancels off. So what happens? You're remaining with limit as h tends to 0. And we have minus h remaining here, h remaining here, h plus 3. Now this is same. So what has happened? It will be limit as h tends to 0 minus 1 divided by h plus 3. I hope this is clear. Now we can apply the limit. Why? Because now if we apply 0, it's fine. Because we have 0 plus 3, so it's 3 in the denominator. But if we applied over here, this h would have been 0 and divided by 0 would be undefined. That's the concept. And now here when we apply the limit, I'm just going to write it over here, minus 1 divided by 0 plus 3. It's negative 1/3. So that is the answer. And here you can use the calculator or use the quotient rule and check the answer must be this. So that's how we solve this up. And now we have to use the second formula as well. Let us do it. So remember the answer is negative 1/3. Here you can see it's minus 1/3. That's the first one. Okay, now even let's do the second one. It's just the same thing, but I'll quickly do it because it's the last problem in this, in the first 4 exercises. So f of b would be 3 by b plus 1. And f of a is 2. We have just done it a while ago. It will be 2 plus 1. That is 1. Why? It's 3 divided by 3. This is it. Now let's substitute in the formula. Limit as b. Here it tends to 2, not 1, because a value is given as 2. Let's substitute 3 divided by b plus 1 minus 1 divided by, what is b here? B is, as it is, sorry, A is 2. Now, can you directly apply the limit? If you apply, it will be 0 and it's undefined. So we do the same concept what we did a while ago. We multiply and divide this by the denominator. Now remember, this is not conjugate. Don't think, oh, I should change the sign. No, only when there is a radical, when you have radical like this, x squared plus 1, something like this, then you change the sign. Okay, and sorry, it should be outside. Then you change the sign. When it is just terms, we need to write it as common term, which is a fraction. You need to just multiply the same term up and down. I'll multiply this by b plus 1 up and down. And now this is going to be 3 divided by b plus 1 minus b plus 1 divided by b plus 1. The entire thing, b minus 2. And the limit remains the same, b tends to 2. Now let's simplify this. We have done this a while ago. So limit as b tends to 2, it's going to be 3 minus b plus 1. But remember, this minus is for both the terms. I will put a bracket. 3 minus 2 terms means I'll put a bracket divided by b plus 1. Since they are same numerator, we just write it up together. Now, if you're wondering how this is happening, imagine 3 by 5 minus 1 by 5. How do we solve it up? 5 and 5 it's same. 3 minus 1 is 2. So we write 3 minus 1. That's 2 by 5, right? 2/5 is the answer. Same way we are doing this. If it was plus over here, then it will be 4/5. You add it up, it will be 4 by 5. So the same concept, same terms, denominator, same thing. And here we have b minus 2. Okay, now what do we do? So let's write the limit as b tends to 2. Here we have got 3 minus b minus 3 because, minus 1. It will be 3 minus b minus 1 because this minus sign is multiplied to both the terms. We have b plus 1, and I told you when this is divided by both these terms, we write it directly b minus 2. Now what happens up over here? It will be limit as b tends to 2, 3 minus 1 will be 2. Okay, so I'll write this first. I'll write this 2 minus b. Now there is a little bit of a problem. I'll tell you what happens now. Plus 1 and b minus 2. You can see these two terms, b and 2, but the signs are an issue, right? There is a rule for that. You can just take a minus sign outside or multiply this by minus sign and swap the signs for these two terms. Meaning, if I have 2 minus b, this is equal to minus 1 times b minus 2. Why? Because I've removed a minus sign outside. This minus sign is gone and this becomes plus, whereas this was positive, it becomes minus. Let me multiply this inside and it'll be the same. If I multiply it inside, it'll be minus b plus 2, or it's 2 minus b, right? 2 minus b, it's the same thing. So that is what we will do over here. We will take out, it's still limit b tends to 2, minus is removed out, and we have b minus 2. Denominator is b plus 1, b minus 2. And now we can cancel this off. Why? Because they are same terms, right? We can cancel because we have removed the minus sign outside. And now apply the limit over here. Denominator, apply the limit. See, above there's nothing. It's minus 1 divided by, see, you can write over here minus 1 directly, multiplied by b minus 2, or you can ignore it anyways. Nothing means it's minus 1, and over here when you apply the limit, it's 2 plus 1, that's negative 1/3. So that is the same answer what we got just a while ago. It's again negative 1/3. So this is how we solve for the second, using the second formula. Any formula, you'll get the same answer, and that's what we do. Now for the next 5 to 12 exercises, we can use any one of the formula. It's OR. See, I've solved both these formulas from till just now. Now this is same problem. I think so we did the same one, right? 3x squared plus 1. So here it's the, yeah, that's already done. So we have done the same thing already, but now it's up to you to choose any formula. What I would personally choose is the second one only. Okay, but there's a problem now. I mean, I forgot to tell you what's the difference. There is no a value. Can you see there is no a value? A is not 1, 2, it's not there. So a is x. We can alter the formula here. Instead of a, you can just write it as x. That will be limit as h tends to 0, f of x plus h minus f of x divided by h. This is h. The second formula becomes again x, that is limit, but now here b tends to x, not a, because we don't have an a value, and f of b minus f of x divided by b minus x. Remember this is very important. So now this is the change what we will get. I hope this is clear. So instead of a, wherever a is there, we just keep x, because a values are not given, they have just given the function, that's it. So this is the formula we would tend to use. Over here, wherever a is there, just put x. Okay, everywhere. Even over here, wherever a is there, we just put an x value. Now I'll solve this over here using this second formula. You can use any, but I'll just choose second because it's easier. So f of b here will be 3b squared plus 1. And what about f of x? F of x is the same given equation, so I'm not going to write it again. See, this is going to save some time, because over here it would have been, you know, applying, writing the formula, expanding and all that. So here what happens is limit as b tends to x. The first term is 3b squared plus 1 minus 3x squared plus 1. Now remember, this is in brackets, divided by b minus x. What do we do here? We can't apply the limit directly. If you put x, x minus x is 0 and it's undefined. Because you're subtracting by the same variable, it becomes 0 here. So let's simplify it then. How can we simplify? Let's see, 3b squared plus 1 minus multiplied inside will be minus 3x squared minus 1 divided by b minus x. And this limit b tends to x. Now what? This plus 1 minus 1 cancels off, so you're remaining with 3b squared minus 3x squared. I'll just write it over here. 3b squared minus 3x squared. 3 and 3 is common, isn't it? So I can remove that outside. It will be b squared minus x squared. And now you can simplify this further. Let me just write it over here. So it's limit as b tends to x. We have got 3 removed outside, b squared minus x squared divided by b minus x. Now here this b squared minus x squared can be expanded as, it's a squared minus b squared. It's a plus b, a minus b, b plus x, b minus x, because we have b and x. So that is what I will do over here. Limit as b tends to x. We have 3 times b plus x, b minus x divided by b minus x. Now can we cancel this? Yes, of course. And what is remaining with us? Limit as b tends to x. We have 3 into b plus x. Now let's substitute the limit of b. B becomes what? X. So it will be 3 times x plus x. What is x plus x? It's 2x. 3 times 2x. 3 times 2 is 6x. That is the answer. Now let's look over here. When we solve this up, 3x squared. If you use the power rule, this power 2 comes down. It will be 3 into 2x. 1 is 0, so it is 6x. Yes, absolutely. This is how we basically solve it up. I hope this is clear. So that's how we solve this problem. Now I have used the second formula. You can even use the first formula and solve it. They have used the first formula. Okay, you might think, okay, there is only so many steps, whereas mine is so much, right? I mean, these were just the formulas. I've just done it in 4 to 5 steps. But as you can see here, they have not done entire steps. They have jumped few of the steps, okay? That's the reason it's very short. If you go through it, you might not understand it thoroughly. But if you find this easy, just go with it. I tend to use the second formula because I find this easier compared to the above one. Now, all these problems are the same thing. I'll do this one and then I will see if there are similar problems. I'll skip it and I'll move to the harder problems. So what do we do here? Again, the same concept, f of b first. I'm just going to use the second formula only. F of b would be b squared minus 2b plus 1. And directly I'll write it in the formula f dash of x, that's f prime of x or derivative, would be limit as b tends to x. We have got what? We have got first f of b here, b squared minus 2b plus 1 minus, what is f of x? See, this is not a, it's x, this term itself, but use the brackets, x squared minus 2x plus 1 divided by b minus x. Now let's remove this. I'm not gonna write the limit because it's just there everywhere, okay? I'll just write the right side, okay? So it's b squared minus 2b plus 1 minus x squared plus 2x minus 1. Now what we can see here is only this 1 and 1 cancels off. What else? We can write b squared minus, okay, I did not write the denominator. Here we have the denominator b minus x. Don't forget that. Even the limit you should not forget. I'm just a bit lazy, writing it all the time. So it's these are basic things you must have it, okay? Now what I'll do is I'll group b squared and x squared together. And then what do we have here? Minus 2b plus 2x divided by b minus x. Now after this simplification, there is a method which we must follow. The method is this. See, if you have a plus b plus c plus d divided by x, this is same as a plus b divided by x plus c plus d divided by x. Why? Because the denominators are same. We can write it up together and add up all the things, right? A plus b plus c plus d, isn't it? For our advantage, if we have this given question, we can split it up like this. Same way over here, we can see b minus x, b and x is there, b and x is there. So we can split it up to our advantage. How? Just like this. Let me show you over here. B squared minus x squared divided by b minus x. Then always add plus no matter what. And then write this minus 2b plus 2x divided by b minus x. This is a trick, or I mean this is an easier method, to do it. Look, it's just like this we have added. Over here there was minus. Now imagine we had minus c over here, and it's fine. Just add this minus here. So when we finalize it, again it'll be minus. That's it. Now if you add it up, you're gonna get the same above equation. So that's fine. It's balanced. Now then, here b squared minus a squared. What is the formula? It's b minus x, b plus x, b minus x divided by b minus x. And what about the right side? Here, if you take 2 outside, only 2, it'll be minus b plus x. So just take minus 2 outside. What is it going to be? It'll be positive b because minus 2 is gone. And minus 2 from positive is gone, so it'll be minus x divided by b minus x. Now cancel it off, cancel it off. The main reason why we did this is to remove the denominator b minus x. If we apply the limit, it would have been x minus x. Now we can apply the limit. This b is tending to x. Now it's all in the numerator, so that's absolutely fine. So what is this? It is b plus x. This is all cancelled. Plus, only minus 2 is remaining, so plus becomes minus 2. So this is the thing. And let's apply this x over here. So this is going to be where there is limit. Everywhere there is limit. B tends to x. Over here also there is limit. Here also limit. You have to write it. Limit, and please write the variables over here. This b tends to x as well. Now here, when we apply the limit of x, it's going to be x plus x minus 2. That is equivalent to 2 plus 2 is 2x minus 2. That's the answer. Let us check this, whether it's correct. Derive it. Here x squared is 2x, from power rule, minus 2. Yes, that's the correct answer. So this is how we solve it up. I hope this is clear. I'm just going to use one of the formula. I tend to use the second formula most of the time. It's easier. You can try with the first formula as well. And over here, the first formula is there. Say it's not so simple. Here they have missed some steps. But if you're thorough with the first formula, go ahead with it. But I'm sure they have not done all the steps here in the solution set. If you do the steps, it's overall almost the same number of steps what I've written over here. Now here, and it's not number of steps, it's about mean understanding. If you understand, then you can skip. If I'm just writing for myself, I would have skipped many steps and directly jumped to the answer. But for understanding purposes, I'm writing it in detail. I will solve this one over here. It's power 3. I remember for power 3 now we will get, in terms of a cubed minus or plus b cubed. We have to use this formula. Now let's first, for this particular formula, it's f of b, that is b cubed plus 2b minus 1. Let's directly substitute in the formula. It's limit as b tends to x. What do we have over here? The first term is b cubed plus 2b minus 1 minus, what is the other thing? It's over here. But now you can put the bracket. I used to put the bracket and then multiply the minus sign, but I'll directly multiply this by minus sign. See, this minus times f of x, right? I'll just multiply this throughout by minus sign. It'll be minus x cubed minus 2x plus 1 divided by, so I'm not writing minus bracket anything because I've already multiplied here, divided by minus b minus x, sorry. That's it. Now here then what happens? Let us simplify. What cancels off? Only minus 1 and plus 1 cancels off. Then everything is there. So here we have, let's write the cubes together. B cubed, you have to write limit throughout. B cubed minus x cubed plus 2b minus 2x divided by b minus x. Again, limit as, see, the reason I'm writing it purposely is you never forget it. Don't forget it in the exam. If you don't write it, you may lose your marks. Okay, that's the reason. Now then, again, what we did just a while ago, we do the same thing. See, b and x is over here and over here. So let me split it out. It's b cubed minus x cubed divided by b minus x. And what about this plus? It's 2b, it's plus only, minus 2x divided by b minus x. The limit is b tends to x. Now what else? Now you must recall the formulas for b cubed and x minus x cubed. See, b cubed plus, so I'll write it as a cubed and b cubed. A cubed plus b cubed is given by, see, when this is plus over here, always remember you start with a plus b, then you write a squared minus ab plus b squared. There is a mistake which many students tend to do. It's a bit of confusion. Now, many students think, okay, if it's plus, everything is plus. No, that is not the case. This is minus. Whereas if it is a cubed minus b cubed, it's a minus b, then everything is plus. A squared plus ab plus b squared. This is the concept over here. This is the formula identity. Now let's substitute the formula here, the second formula. Remember, here what happens? It's b minus x, then everything is plus b squared plus bx plus x squared. That's it. What do we do? This is a and b, right? Instead of a and b, we have b and x. So we write this same identity. You must remember this identities. Here left side limit as b tends to x. Now if you're thinking, why don't we just apply the limit? If you apply the limit in this part over here, x minus x is 0. It's entirely undefined. We can't. But now you can see there is b minus x, which cancels off. And there is no denominator b minus x, so we can apply the limit. But right side, remove the 2 outside. And what does remain? B minus x, and you have b minus x here. Cancels off, remaining is 2. So now you're remaining with limit b tends to x. We have b squared plus bx plus x squared plus 2. And what do we do is we substitute this x here, right? It's going to be x squared plus x times x plus x squared plus 2. Now this is basically x squared plus x squared plus x squared plus 2. How many times x squared? It's 3x squares plus 2. That is the answer. Now let's just check this as well. 3 comes down. Yes, it's 3x squared plus 2. Yeah, that's the answer itself. So this is how always verify your answer. If you have got any error, you can easily check it, and then you can trace back where did you do wrong and then rectify it. So this is how we solve it. It's getting a little bit lengthier, right? But that's how we solve these problems. Over here again, see, they have skipped many steps. These I've just tried as less as possible, but still you can skip some steps over here. Say over here I've done many, right? You can't jump, but this is for understanding purposes. I've done it all. Now once your denominator is rid of minus b minus x, then you apply the limit and easily get the answer. Let's move on to the next problem. And if you're already tired till over here, you can stop. If you've understood the topic thoroughly, you can skip ahead. You don't need to watch each and every problem. It would be a nice practice if you try to solve this by yourselves and then check for the explanation. Now about this problem here, it's a little bit tricky, because if you're going to use the second formula, there's minus. What happens over here is you will have x power 4, it'll be b power 4 minus x power 4. This identity is way too big. So let's use the first one. What happens when you use the first one is it'll be whole power 4. It'll be like a plus b the whole power 4. If you recall Pascal's triangle, we have that identity. Now, if you're thinking how, I can't remember, I can't memorize, then I'll just recall a few things. It is about Pascal's triangle. I hope you remember this. You have done this before. So this is to find any identity. This is 0, 1, 2, 3 would be over here. Ends are always with 1. Middle, you just add them up. 2 plus 1 is 3. And again over here 3. And 4 will be over here again 1, 4, 6, 4, 1. So now what this means is, if you want a plus b the whole power 4, you need to know this first one is the coefficient 1 a to the power 4 plus 4 a to the power 3 and b power 1 plus 6 a to the power 2 b to the power 2 plus 4 a just a power 1 and b power 3, and lastly we have plus b power 4. This is how we can get any identity. If you keep on going further, the Pascal's triangle, you can extend it and you'll get power 5, power 6 and so on. Now this is how I would do it, because this is the best way to do it, and because the first formula if you use, since we have power 4, you have to use the power 4 identity. You can use this for any a power a plus b the whole power 2, power 3, power 4, power 5, and so on. I'll just write this over here, keep it over there, and let's solve it out. But here I'm going to use the first formula. This is going to be too difficult because of the identity. How we can solve this first thing, f of, instead of x, this is all x, okay? No a this time because a value is not given. Instead of x, we put a plus h, that is x plus h, sorry, x plus h. And this is going to be x plus h the whole power 4 minus 2 into x plus h the whole squared plus 1. Now when we simplify this, f of x plus h, what happens? We have to use this identity in this case. It will be x power 4 plus 4 times x cubed h plus 6. Since it's plus, it's all plus. If it was minus, then the second term is minus, right? You have to put minus and it changes. This is all Pascal's triangle. Just recall this. This is from grade 10, by the way. Now here it is x squared h squared plus 4x h cubed plus h to the power 4. Okay, that is the expansion of the first one. Minus, we have 2 times what? A plus b the whole square. A plus b, it's very simple. It'll be a squared plus 2 times ab plus b squared. And now we will substitute over here. It'll be x squared plus 2 times xh plus h squared plus 1. Isn't it so big? But this is the thing, you know. And now we will try to simplify x power 4. What happens over here? We have 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the power 4 minus 2x squared minus 4x h minus 2h squared. What did I do? I just multiplied this minus inside plus 1. Now can we cancel anything? Oh, sadly no, nothing. So we just leave it like that. And now what we have to do is this entire thing, right? We have to substitute this whole thing. It's a bit long. I hope this doesn't come for exam. It's just too lengthy and it becomes much messy, you know. This is basically, f of x plus h. You don't need to simplify. You can't simplify anything further as of now. What about f of x? Okay, I'm not going to write it. It's already there. So now I'll directly substitute in the formula, okay? The first formula, we'll get limit as h tends to 0. This term is all this term here, x power 4 plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus h power 4 minus 2x squared minus 4x h minus 2h squared plus 1. Subtract it with this terms. What happens over here? It's x power 4 minus and minus becomes plus 2x squared because we have to minus negative all these terms, minus x squared, but this is already minus, it becomes plus, and lastly we have minus 1. 1 cancels off. What about this? 2x squared over here cancels off. What about x power 4? Yes, this also cancels off. So now it's not less, but something little bit lesser, you know. Now let's write all the remaining terms divided by h. So limit as h tends to 0. You can't make the limit of h 0 now because it'll be undefined. So let's write it out. We have x to the power 3h. Okay. Then plus 6x squared h squared plus 4xh cubed plus h power 4 minus 4xh minus 2h squared. Did you see what happened now? Okay, that is a very bad line. Okay, again, oh my god. This is me getting roasted in my mind, I guess. And now we have h. So you can see here in the numerator, we have h common in all. H common in all of these terms. So we can rearrange and write this h outside distributive property 4x cubed only because h is gone plus 6x squared h only because 1h is gone plus what happens over here? We have 4xh squared plus h cubed minus 4 x only minus 2h divided by h, and that limit h tends to 0. Now because h and h is cancelled off, we can easily apply the limit. So 4x cube remains. But what happens over here is this limit becomes 0 plus 0. Now again over here h is there, so it's 0. What happens over here? Plus 0. Minus 4x remains minus 0. So this is it. Now let's remove all the zeros and write. It'll be 4x power 3 minus 4x. Is that correct? Let's just solve it over here. It'll be 4x power 3 minus 4x. Yeah, that's correct. So that's the answer. Now, I know it's lengthy, but it's simple as well if you understand the rules. So if you just know this formula to substitute. Now here, I wouldn't be using this because here it'll be a power 4 minus b power 4. And it's very complicated. So use the first one. It's or any one. See, you can try using the above one. It might be easier for you, but there are many problems where the second formula is much easier. We have seen it already before, but in some cases you have to use this formula. So that's how we solve it up. And I'm sure this is no way to get this answer. It's actually this long. The solution set doesn't show it so properly. Now, this is not the accurate way to solve any of these problems, but if in the exam you just can't remember this method, do this. Just do the power rule. Right over there you're doing power rule and do 4x power 3 minus 2 into multiplied by again over here 2x power 1 plus 0, and then write it is 4x power 3 minus 4x. I'm sure you're not going to get the full marks, but at least few marks you might get, for this method. You might get a couple of marks, and over here the answer is correct, so 1 mark over there. So at least some marks, okay? And if you know the formulas, please write the formulas at least, and you might get some marks over there. So that's how we can solve it up. Okay, this is seeming like it's just not going to end, isn't it? So I'll quickly do this one, and I hope the other problems are similar, so we can stop. I'm going to use the second formula itself over here. So here it's going to be f of b that is equal to 3 by b plus 1. We have done a similar one before, but it's just that a value was given. Here a value is not given. So here we have 3b plus 1 minus 3 by x plus 1 divided by b minus x. Now here there is a little bit of a problem. The denominators are not matching, isn't it? So what you need to do in such cases is whatever is the denominator here, you multiply over here and divide it over here, b plus 1. And this denominator to the other side, x plus 1 multiply and x plus 1 divide. That's the concept. Now here when you simplify now, what's going to happen? It will be 3 into x plus 1 minus, because now the denominator both the sides will be x plus 1 b plus 1, and the right side it's going to be 3 into b plus 1. That's the thing. And what next? Here divided, this entire thing is divided by b minus x. I hope so much is okay. Next step, what you can do is you can say this comes down itself, your b minus x, but the problem is we don't want that. We need to simplify this, isn't it? So multiply this 3 inside. Over here there is limit. Over here also there is limit as b tends to x. Okay, the limit over here is also same thing as b tends to x. Now this denominator and this can be written together because we had seen before a divided by b divided by c is basically a by b times c, right? So here I'll multiply 3 inside, distributive property, and even over here with minus 3. It'll be 3x plus 3 minus 3b minus 3 divided by, we have b minus x, x plus 1, b plus 1. Now plus 3 minus 3 cancels off. You can remove 3 outside. Now here remember this b must be positive. So what you do is take minus 3 outside. There is all limits everywhere. Limits is there. Okay, here also limits is there. Minus 3, when I remove it outside, what happens is this b becomes positive and minus x divided by b minus x and the other two terms, x plus 1, b plus 1. Now this cancels off. You have minus 3 by x plus 1, b plus 1. Now here limit is what? B tends to x. So let's substitute. It becomes minus 3 divided by x plus 1 as it is, but this b also becomes x, so it will be x plus 1, and it is minus 3 by x plus 1 the whole squared. So this is the answer. And yes, that will be the answer because it's like, 1 by x, 1 by x formula of derivation is minus 1 by x squared, but instead of 1 by x, we have x plus 1, but the same thing, minus 3 divided by x plus 1, this whole thing becomes squared. So that is the solution. Now I've used the second formula and done it. You can use the first one and do the same as well. Only thing is the limit becomes 0. Here the limit x tends to, b tends to x. So b changes to x. It's minus 3 by x plus 1 the whole squared. Again, this is similar. Please try it by yourself. There's no much difficulty in this. You can see over here the solution set as well. Okay, over here everything is done in detail, I believe. Just remember, when the denominators are different, you multiply this denominator up and down here and this other side to the other side. Okay, I will do this one, square root. Again, I'm going to use the second one itself. F of t is there, so don't take a as x. Let's take it as t because that is the variable over here. F of b will be square root 3b plus 1. So what is the formula? Your limit as b tends to t, this time not x, we have square root 3, this t becomes b plus 1 minus, then what do we have is over here, f of t itself, just write the same thing, 3t plus 1 divided by, we have b minus t. Now this is a problem. Why? Because this radicals, not a problem. I mean, radicals are there. We can't directly apply the limit. If we apply limit of b to t, it will be undefined. Whenever radicals are there, remember conjugate, multiply and divide by the opposite sign. So over here, I multiply this by 3b plus 1 plus 3 radical 3t plus 1. We have done this problem before, right? Radical, you multiply the conjugate. Your a value is not given, so it's just that we have b and t. So here 3b plus 1 plus 3t plus 1. And now let's solve it up. Here we will have b minus t multiplied with root of 3b plus 1 plus root of 3t plus 1. Now up above, directly I'm going to write it will be a squared minus b squared. So the radical symbol goes off. It will be 3b plus 1 minus 3t plus 1. Here we have limit as b tends to t. Again, limit as b tends to t. This 3b plus 1 and minus sign is multiplied inside, will be minus 3t minus 1. Plus 1 minus 1 cancels off. Down denominator is the same. Square root 3b plus 1 plus root 3t plus 1. Now what else do we have when we see here? 3 is common out, so 3 can be removed outside and we have remaining with b minus t, and down over here also we have b minus t, isn't it, which cancels off. And then what is remaining is 3b plus 1 plus root of 3t plus 1. Now when this denominator cancels, I mean this b minus t term cancels, now the limit b tends to t, if you put over here, it would have been 0 and it would have been undefined, but now there's no problem. Why? Because it's cancelled off. So I will apply the limit. The numerator is only 3 and the denominator, instead of b, it becomes t. That's fine. Plus the second term is what? 3t plus 1. Now here, imagine you have x plus x. It is 2x. Same thing, root x plus you can write 2 root x, isn't it? The same way over here, we can write 3 divided by 2 root 3t plus 1. This is the concept over here. And that's it. That's the answer, guys. So the final answer will be 3 by 2 root 3t plus 1. There we go. So that's the final answer. And this one is just like the previous one. So I would expect you to solve it by yourselves and then check the answer. Here we have, the same method. Everything is same. We'll get 2 divided by 2 root t, 2t plus 4. But 2 and 2 can cancel off, and you can write 1 divided by square root of 2t plus 4. And finally, that is the end of the topic 17. Before we move on to the next question, a humble request to all of you. If you're finding these videos helpful, please do share it with your friends. Let them know about this channel. There are more than 1,000 videos related to math. Another humble request to all of you, please do subscribe to my channel. I want to thank all those who have subscribed to it. As you can see, only 22.3% of my viewers are subscribed to the channel. It would mean a lot to me if you could just hit the subscribe button. In this video, we will learn about implicit derivation. Here, before we begin with the problems, let me just tell you a little bit about implicit derivatives. Now, imagine we have a function x squared plus 3x minus 5. Okay, we need to derive this. That means d by dx. What does this exactly mean? We are differentiating or deriving with respect to x. So here, this power rule, it'll be 2x. And what is the function? We derive it as well. What is the derivative of x only? D by dx of x would be 1, isn't it? When we derive x term, it's 1. So we just don't write it as multiplied by 1. We just simply leave it, because multiplied by 1 will be this value itself, isn't it? So 2 by power rule, the 2 comes down, power comes down, and over here reduce the power by 1, it'll be x itself. Then what about this? Plus 3, and when we derive x, it's again 1. So it's gone, and this is a constant function, so it's 0. So this would be the answer. The same concept is used even for y, but let me start with a simpler problem. Derivative of y, when we write dy by dx over here, since over here we have y, that's it, dy by dx is the answer basically. But since this is huge term, we denote it in a simpler way, that is y prime. This is how this is called Newton's denotions. So this is y prime or y dash. Y, that this prime is a single dash on the top like a apostrophe. This means it's derivative. So that's it. Now what if we have derivative of y power 2? Then derive the power first. 2y power 1, we don't write the 1, just 2y. And then we will have again y prime. Over here also we derive this x term, but it's 1, so we leave it. We leave it as it is. Over here we have to mention this y prime. Now what if it's y to the power 3 derivation? d by dx of y power 3 would be 3y power 2 into y prime. So these are some basic differentiation. Let me just write a few which really helps you out to compare. Now, if you have derivation, d by dx is derivation of, say, x, and d by dx of y. And then let's try derivation of x squared, derivation of dx of y squared, and let's try another one, y cubed and x cubed. X power 3, and over here d by dx of y power 3. You can pause the video now, write the answers over here by yourselves, or you can continue watching if you are getting confused. See, this is x, and we always derive with respect to x. See now here, y prime of x means it's derived with respect to x, dy by dx. This is what it means. But we simply write it as y prime, or you can write y prime of x. That's fine. Now let me solve it up over here. This is gonna be, let me just remove that previous ones. So here let's use the power rule itself wherever we can apply. Otherwise we just use the rules which we know. If it's only x, it's 1. Here it will be 1 times y prime. I'll write only y prime. You can write y prime of x, but I'm just going to write y prime. That's fine. Here it's 2x. Here it'll be 2y, y prime. It'll be 3x power 2. Here it's going to be 3y squared, y prime. This is y prime or y dash. It means derived with respect to x. So if you compare these two, it's almost the same here. Only a y prime is being added whenever we derive y. Whenever we derive y with respect to x, we have to add this y prime. This is the only difference. If you understand this concept, then these problems are going to be pretty simple. Now imagine this is like x only, but like another variable, how we derive x. If we have, say, cos x and then x power 3, we use product rule, right? So same way over here, imagine these are two separate terms, so we have to use product rule here and solve it up. So now here, let's start solving it. I'll recall the product rule. Imagine a, b, this first term is considered to be a and second is b. You might also see it as u and v or any other thing. X and y also is fine. Just for your understanding, it's a prime b plus a b prime, or u prime v plus u v prime. Henceforth, I'll be using a and b for simplicity purposes, because my u and v sometimes won't be differentiable. So a and b is easily differentiable. I mean, you can understand the difference of it. So this is the product rule. Whenever two terms are multiplied, now here these two are multiplied. So what is the derivative of the first term? It'll be 2x. And what is this? Second term will be written as it is, plus, what about the second part? First term will be written as it is, and now we derive 2y. But don't forget, whenever we derive y, we have to multiply it with y prime, plus 3y, but it's y prime here, equals 4. Why only 4? Because x will be 1. So that's the answer. I mean, it's not the answer, sorry. This is the first step. This is very important step. A lot of marks are awarded to this step mainly. And then the other simplification. Now, once you're done this, leave the y prime terms alone. Leave these over here. See, I'll write the two number first. X squared y, y prime. So you can keep it as it is, but generally what we do is numbers are written first and then the variables. So x and y comes later. And over here, x squared, y and y prime, isn't it? Plus, over here we have another prime. See, I'll just mark them up. We have y prime here and here. So only these two terms are left over here at this side itself. And what is this? It's 3y prime. That is equal to 4 at the right side. Now, what about this term? Since it doesn't have y prime, we take it to the other side and it becomes minus 2x y squared. Now, here we can see this y prime and y prime both exist. And there's no other term without y prime. So let's take it as common term out. Y prime is removed common. So you're going to remain with 2xy plus 3, that is equal to 4 minus 2xy squared. Now, y prime is what they have asked to find. Y prime, in the sense, it's y prime of x, okay? Because it's all derived with respect to x. Now, even for exam, if you write y prime, that's fine. I generally tell my students it's fine because, this is many of the students write it as y prime only. They don't write it as y prime of x. It's okay. If you can write it, then it's fine. Write it as y of x every way. I mean, over here when you derive it, y prime of x. So now over here, the above term, this term will be above over here as it is. But what about this term which is multiplied here, moves to the other side from down? This is multiplication, goes to the other side and becomes the denominator or divided. So it's 2x squared y plus 3. So this is it. So this would be the answer for the first one. Similarly, I will be solving many other problems. If you have understood it thoroughly, try to view a few more and then just move on. But I will try my best to solve all these problems. So that's how we do this. Now I'll remove all. I hope you have remembered these formulas over here. You can just write it out anytime and solve it by yourself, these formulas. So this was the answer, I believe. Yeah, that's it. Now over here, yeah, there's no problem. But sometimes, they might have the simplified form in the solution set. You may not be simplifying as much. It's okay. Don't worry about it. As long as you've got y prime at alone and everything else on the other side, it's okay. That will be correct. Now let's solve this one over here. 3 outside. Again, we have to use product rule over here. A and B. See, AB would be equal to A prime B plus AB prime. So it is 3x. Okay, now derivative of x. Prime is the derivative, right, of the first term. Is what? 1. So it will be 1 times y to the power 3 plus. Now A will be as it is. Derivative of y to the power 3 is 3y power 2 and y prime. Minus 4x x will be 1, so it's just minus 4 equals 10. This 2 comes down and multiplies with 10, so it'll be 20y y prime. I hope this is clear. This is just basic derivatives. 2 comes down and multiplies with this 10, and therefore we get this 20 y and y prime. Y over here, it's y only because 2 minus 1 is 1, that will be y. Now here we will simplify and multiply this 3. I'll do step by step. Y to the power 3 plus, here 3 I'll write it at first, x y squared, and this is y prime. Now why do we write this y prime of x as generally? Because y power 1 is not same as this y prime which I mentioned. So we just write it as y prime of x. So it's easily understandable. But as long as you are okay with it, you understand and differentiate it, that should be okay. That shouldn't be a problem, okay? Now, in my case over here, whatever I'm using y prime is this, okay? But I'm just not writing it everywhere. That's it. Now then, we will start solving the remaining part. Over here, minus 4 is equal to 20y and y prime. Now, our goal is to get all the primes together and then now everything else to the other side, isn't it? So what I can do is I can take this 4 to the other side, it becomes plus, and this part I'll get it in. You can do it in the next step, but first thing is we have to multiply this inside. It'll be 3y power 3 plus 3 times 3 is 9xy squared times y prime. And this I will take it to the other side of equal to, so it will be equal to positive 4. Minus becomes plus. And what about this? This becomes minus 20y y prime. Now then, here we need to group only the y prime terms. So I'll take this to the other side. It will be 9xy squared y prime minus 20y into y prime. That is equal to 4 minus 3y cubed 9. Sorry, it's plus. Now, oh, I got drawn away. This is a single term, guys. It's 9xy squared y prime. Sorry, I shouldn't write that. Don't do the mistake which I did. It's just this term that moves to the other side. Just this first term to the other side will be 4 minus 3y cubed. Now here we can see y prime and y prime are same. So we remove it outside. And what is remaining? 9xy power 2 minus 20y are remaining, equals 4 minus y 3y cubed. Now what else? Here take this entire term to the other side. So it's y prime is equal to 4 minus 3y power cubed. And we have 9x, this is x not multiplied, y squared minus 20y. So this would be the final answer in this particular problem. So it's basically you do the derivative. This is very important, applying the rules and making the derivative of the entire sides, all the terms. And then what you do is gather y prime to one side and everything else moves to the other side. That's it. So here we get the answers. It is now over here. You can see there is one difference. I'll tell you how why it is written positive 3y cubed minus 4 and positive 20y and minus 9xy squared. It's up to you guys. I would personally leave it like this and you should get full marks, no problem. But imagine you take a minus sign outside from here. If you remove minus, the signs are going to flip. It will be positive 3y cubed minus 4. That will be the above term. And even over here, let's take a negative term out. So then you will have positive 20y minus 9xy squared. So this would be the case or situations. Now minus and minus cancel. So you are having 3y cubed minus 4 divided by 20y y minus 9xy squared. I hope this is clear. This and this are the same thing. I've just rearranged it and I have written it over here. So that's how we solve it over here. That's the answers. Now we will solve the seventh question. Before we solve, I'll write some identities. The derivation of square root x is given as 1 by 2 square root x. The product rule we had done, a times b, when there are two variables over here. It will be a prime b plus ab prime. Let's solve it out. Here I'll directly use the identity. It will be 1 by 2 root of x and y, square root of x and y, multiplied with whatever is inside. What is inside? It's x and y. Now we have to use the product rule. Derivative of x is 1 times y plus x times y prime minus this 2 comes down. It's going to be 4 times 2. It's 8y times y prime. That is equal to 12. Now let's, now is this 12? So don't do the mistake I did. It is 0 here. So now what can I do? I have over here two terms. There is y and y prime. Can I directly remove y prime? No, it's not possible. So first let's multiply this inside this term over here. So it becomes y, I'm gonna multiply this here and here. 1 is just 1y is just y. So y divided by 2 times square root x and y plus x y prime divided by 2 square root x y minus 8y y prime. That is equal to 0. Now we can take this to the other side. Now I'm 100% sure in your textbook they generally don't keep fractions. So I will do this as the textbook method and then I will tell a shorter method. Now from here I'm going to change the color because your textbook solutions are generally the solutions. They require you to not have any denominator. They require to have everything in the numerator. So what you can do is, now you can see there is 2 square root xy, 2 square root xy. Now if you multiply everything over here by 2 square root xy, what happens? You multiply this by 2 square root xy, this and this cancel, so you're remaining with y. What about over here? You will have plus xy prime because it cancels again. But here you will have 8y y prime multiplied by 2 square root xy. That is equal to over here 0 times anything is 0. I hope this is clear now. Now what you can do is this y is over here, right? Take it to the other side. You will have y xy prime minus 8y. Now I'll just simplify this. What is 8 times 2 here? It's 16y y prime square root xy. That will be equal to minus y. Now you can see this y prime, so let's take it as common term outside, x minus 18y square root xy, because I've removed this y prime outside, and what is remaining? It's only x minus here 16y and square root xy equals negative y. Now the final answer would be y prime will be equal to this, whatever is multiplied to the other side becomes denominator. Now why did I remove this denominator over here? Because you already get a denominator when you simplify, but if you have two denominators it's just complicated, right? That's the reason. So the final answer would be y divided by x minus 16 y square root xy. So this would be the answer. Now here, just a quick reminder, let's understand one thing. This is the most desirable answer, but this is not only the correct, this is not the only correct answer. I will now remove whatever I've written over here in black and I will rearrange this over here directly and I'll solve it. Okay. Now this is correct. Don't get me wrong. This is absolutely correct. But there is a simpler way I feel, which I will just show you now. Let me just take it all up. Over here it's all gone now. Okay. Now what we do over here is just take this term to the other side directly. That will be xy prime divided by 2 square root xy remains minus 8y y prime remains. That is equal to minus y divided by 2 square root xy. This entire term is to the other side, so we have added a minus. Now if you want, okay, is this minus for the entire term? Yes, absolutely. You can just write it over here. It's fine. It's the same thing over here, over here. Now then, y prime and y prime, I'll remove it as common term outside. So what remains is x by 2 square root xy minus a to y. Because y prime is removed outside, so you're remaining with x divided by 2 square root xy. And over here, y prime has gone only 8y is equal to negative y divided by 2 square root xy. Now you can take this entire term to the denominator, but you can see it looks very shabby, isn't it? It will be y prime is equal to, the numerator will be y, negative y, denominator over here will be this 2 square root xy multiplied by x divided by 2 square root xy minus 8y. I hope this is clear. You can leave it over here. This is y prime. Over here we are dealing with y prime. This is y prime of x. But if you want to go further, you can just multiply this inside. What happens is this cancels off and you will have the same answer what we had. You can stop over here. You must technically get full marks here as well. But anyways, let me just write the final answer. What it would look like? Minus y divided by this multiplied inside. It cancels off, so x is remaining minus 8y. 8 times 2 will be 16. Sorry, let me write it as 16 square root xy. This is the same answer we got any method, but over here you can just stop at this particular method, so it'll be just 3 more steps. But since your fractions, it'll look a bit complicated, like too huge, you know. So that is the thing. So that would be the answer over here, and you can see that's the final answer. Now over here, see, we have, yeah, there's nothing wrong in this. See, what this is the answer. What we have done, what they have done over here is this minus sign is removed and this minus sign is removed, and they have just rearranged the signs. You can leave it like this itself. That's more than enough. They have just done one extra step. Since it's all writing exam, it's more than it's fine. You can keep it however. This is also the correct answer. I just realized there's question 8 as well. Let's solve it up over here. Now, what I would do for this, it's trigonometric function, sine is cosine, so let me solve it up. Cosine xy. Then what is xy derivative? Over here we did the product rule, right? It will be 1y plus xy prime, that is equal to 2x plus 0. Now here then, since over here we have cosine, how would you go to simplify this? All you need is the same thing. You multiply this inside. This is y, right? It'll be cos xy times, this is a single term. Now don't multiply this y inside here, because this is let me just write over here, cos x, imagine cos x multiplied by a plus b. This is going to look like cos x times a plus cos x times b, or you can rewrite this as a cos x plus b cos x. Okay, you don't multiply it as cos xa. This is the degree over here, right? That remains there itself. Cos x, you can't multiply. You multiply it as a coefficient. That's what happens. So here also, I can directly write this y over here. Why? Because this is not going to be multiplied here. It's a separate term. It's multiplied to it. Then plus, I'll write xy prime, and you have cos xy here as well. That is equal to 2x. Now, where is y prime? Only over here. So what I'll do is I'll take this to the other side. It's going to be cos y prime cos xy. That is equal to 2x minus this entire term, y cosine xy. Okay. Now, this y prime over here remains. And then leave y prime. What else? Take it to the other side. It's going to be 2x minus y cosine xy divided by x and this entire term cos xy, cosine xy. So this is the answer. This is a simple one. It's just that, you know, if you know how to multiply this, it's very straightforward. But just remember this, these are coefficients. They are not multiplied inside the degree, not over here. They are multiplied as a coefficient. That's it. That will be the answer. So here are the solution. Now over here there is no methods, guys. See, you should do the steps, okay? Don't just write this directly the answer. You won't get full marks. Please make sure what I've done over here, the steps are very crucial. You can move ahead along in your own pace, but I'm going to solve as many problems as possible here. Moving to the question 9, here you might be thinking, okay, we can directly use A by B, that is the quotient rule. That'll be A prime B minus AB prime divided by B squared, right? Yes, you can do it, but the answers matter. Answers vary. If you do that entirely, your answer will be entirely different than if you look carefully over here, there is only y. See, when we come to this problem, you can see the differentiation. Over here we can manipulate the question itself, because over here you have y, only y in the denominator. Let's multiply throughout by y and make this a single term. What I mean is, if you multiply throughout by y, this and this cancel, so you will have. Moving to the question 9, when you look at this, you might be thinking, okay, we must use A by B equals A prime B minus AB prime divided by B squared. That's the quotient rule, isn't it? But let's wait a minute. You can solve it like that, but it'll just be more complicated. Whereas there's a simpler way you can manipulate the question by just removing this y to the other side or multiplying throughout by y. What happens is the question becomes x plus 3 equals 4x plus y squared y, and this y squared y, sorry, over here it will be y as well, because you're multiplying these both terms by y. It will be xy, and over here y squared y will become y to the power 3, isn't it? Y cubed. So you can rearrange this question easily to this. Or you can multiply throughout by y, the same thing, y cancels here, and you will be multiplying only y at the right sides for these two terms. Now let us derive it. It'll be so easy. See, 1, because x will be 1, equals 4. Over here you have to use the product rule, which we have used many times before now. 1 times y plus xy prime plus over here 3y power 2 into y prime. And now here let's multiply this 4 inside. It will be 4y plus 4xy prime plus 3y square y prime. Over here we have 1. And now let's take this 4y to the other side. Will be 1 minus 4y, that is equal to 4xy prime plus 3y square y prime. Now let's take this y prime common outside. It will be y prime into 4x plus 3y squared. And over here we have 1 minus 4y, isn't it? Let's take this whole thing to the other side. We get 1 minus 4y divided by 4x plus 3y squared. That is y prime. I hope this is clear. Now you might be thinking, why can't we use the product rule here? Yes, absolutely you can use, but the values will be different. But as long as you have done it properly, you'll get a different separate set of answer, but that is also valid. But this would be more desirable in the sense, whenever you look at the question and it's easily, solvable, easily rearranged, then do it like this. So that would be the answer. Now over here they have written this term first, and that's fine. It's the same answer altogether. You can write 3y squared first or 4x. It's fine. Now let's look at the right side here. In this case, I wouldn't go to remove this x plus y. Why did I do it over here? Because both the terms in the left side had the same common, same denominator. But here, if I'm going to remove it, then it's going to be 3x into x plus 2 plus y cubed into x plus 2. It's going to be such a big complication. So in such cases, I'm not going to do that. All I will do is, let me use the directly, let's differentiate on both the sides. That will be 3 over here, x will be 1 plus 3y squared multiplied by y prime, because this is 3y power 2, then again y prime is multiplied, minus, here it is a by b, that is equal to a prime b minus ab prime divided by b power 2. Some students put this as plus, which would be wrong, and some students forget this b power 2, they just write b, or they use the derivation over here as well. So be careful with this rule. Now here what happens is, this is the above term, 4y is a, so I will have to derive it. It will be 4y prime Now this entire thing, I'll write it together in the bracket, multiplied by b, that will be x plus 2 minus, this remains, 4y remains, and derivation of x plus 2 is just 1, so I'm not going to write it, divided by x plus 2 the whole power 2. That is equal to 10x squared. What happens over here? Derive it. 2 comes down to be 20x. Now, see, now we have to multiply this x plus 2 the whole square throughout. Why? Because we have over here a prime, right? So we can't have this denominator. And over here there is no prime. If in case we had prime here and prime here, then it would be different. We can just leave it and then rearrange it there. But see, there is prime here, no prime. So then what we have to do is we have to multiply this denominator throughout all the other terms. These two terms have it, so leave it. Whereas all the others, you need to multiply. Let me write from here. X plus 2 the whole square. 3 times x plus here. See, this prime is already there, so it'll be y power 2. I'll write prime at the end. So it's x plus 2 the whole square multiplied by y prime minus. Now here we just write 4y prime. I'll multiply this inside. See here, minus is being multiplied to this term. 4, let me just write x plus 2. Okay, this is minus. But now look at the next term. This is already having a minus. So when I multiply this minus to this, yes, it became negative. But then I do this minus and minus, it becomes plus 4y. Do I have to write anything down? No, because this has already been multiplied, right, to the other term. So this is gone over here. Equals 20x times x plus 2 the whole power 2. Now then, what else we will do is we will just keep the y prime terms. That is, see over here, this is having y prime, this is having y prime. All the other terms to the other side. So let me write 3y power 2 x plus 2 the whole square y prime minus 4y. Let me write y prime at the end, x plus 2 y prime. The reason is I'm going to remove this common out in the next step, equals 20x into x plus 2 the whole squared. This to the other side would be minus 3x plus 2 the whole power 2. And then what do we have here? 4y, it will be to the other side minus 4y. I hope this much is clear. And then we just take this y prime outside. And now basically you're remaining with 3y squared into x plus 2 the whole squared minus 4 times x plus 2 equals 20x into x plus 2 the whole squared minus 3x plus 2 the whole squared minus 4y. It's a bit lengthy one. And the last final answer would be y prime as this entire terms, 20x into x plus 2 the whole power 2 minus 3 into x plus 2 the whole squared minus 4y divided by, what happens here, 3y squared into x plus 2 the whole squared minus 4 times x plus 2. So this is the final answer. It's lengthy, but once you derive it, see, this is the most important step, deriving, and this is all rearranging basic algebra. So now once you do all this, here what happens? You're just grouping the y prime terms and then taking everything to the other side. Over here you can see they have not, see now they have not done this entire is answer. See, they have taken the y prime out, but they have not taken this to the other side. It's you can vary the answer. Now what I have done is very basic, just follow the methods and just take it to the other side. Now here you can see x plus y is there, x plus y, you can remove this common out and all that. You can manipulate this various ways. In your textbook, I mean in the solution set, they are manipulated differently. That's fine, it's up to you. Now in fact this one is the same as the previous one. You can see the same thing. So I won't solve this. Over here you can see the more detailed answer. What we got is also correct. It's just that we can take these terms outside and rearrange and make it beautiful, like beautiful looking. That's it. But if you do this, it's more than enough. This is also the correct answer. You can compare the answers over here. Let's do these. Now if you're thorough already, you can move ahead at your own pace. But I'll anyways try to solve all these. What is the derivation of e to the power x? The derivation is the same, e to the power x itself. Now here we have e to the power x, so let us it'll be chain rule and then product rule. It'll be first, when we derive this, it'll be e power x power 2 y. Y is in the numerator, guys. Multiply it with the product rule. What is the product rule here? Again, a b equals a prime b plus a b prime. Now it's always better to write the rule and solve it up, because even sometimes when I sometimes solve it directly, I might miss out a term. So that's why I generally write it out and easily solve it. So it's going to be differentiation of the first term, that is 2x multiplied by y plus, now here you keep the first term as it is and only derive the second term, minus e to the power y multiplied by y prime, chain rule. This is the derivation of e power y, but then y prime equals 1. Now here then multiply this term, ex squared y multiplied with this will be 2xy plus e again x squared y into x squared y prime minus ey y prime equals 1, which doesn't have any y prime term. This is the only one, right? So I will leave ex squared y, this term, x squared y prime and minus ey y prime equals 1 minus ex squared y multiplied by 2xy. Because this doesn't have any y prime term, I'm going to remove this y prime common, and you're remaining with ex squared y multiplied by x squared minus e to the power y. That is equal to 1 minus ex squared y 2xy. You can write this 2 over here ahead because the numbers are generally written at the first. So that will look like this. 2 e to the power x squared y xy. Now in the writing exam you can leave this over here. It's all correct. It's fine, you know. And this one will be ex squared y x squared minus e to the power y, and over here we have y prime. This would be the final answer. There might be any variations similar over here. You can have this minus sign removed and here and there, but as long as you understood how to derive and rearrange, that is more than enough. Now let me do this one as well quickly. Question 12 would be product rule here. So product rule, again, I'm just going to write it quickly, and it is the derivation of the first one, e to the power y plus x e to the power y minus, what happens here, again it's a product rule, 3 outside. What happens here is y prime, because derivation of y would be y prime multiplied by sine x plus, now y remains. What is the derivation of cosine sine x? It's cosine x positive. Okay, and that is equal to 1. If it is cosine over here, it will be minus. So remember, that's very important, the signs. Now then, what do we want is, okay, is this now here? Can you see I've done a mistake, right? The first one is derivation of x is 1 ey, and second part is a will be as it is. The derivation of ey will be ey and y prime. See, I just realized that just now. If I had not realized, then I would have done wrong, and then I would have traced back the mistake. It would be a long error. So just make sure you do this step very accurately. Now here I'm gonna remove this term to the other side because there is no y prime. I'll just leave this x e y prime term, and then I'm going to multiply this minus 3 inside here. It's going to be minus 3y prime sine x, and this is again minus 3y cosine x equals 1 minus e to the power y. Why? Because this goes to the other side. 1 times e power y is e power y itself. 1 minus e power y. And now y prime and y prime, let them be here. Y prime minus 3. I'll write sine x y prime. Because I'm going to remove this y prime, I wrote it at the end. This will be equal to 1 minus e to the power y. This, when it goes to the other side, it becomes plus 3y cosine x. Now what do we do here? We take this term common outside, x e to the power y minus 3 sine x. That will be equal to 1 minus e to the power y plus 3y cosine x. And lastly, the same thing at the right side, no changes here. 3y cosine x divided by this entire thing divided by e to the power y minus 3 sine x y prime. I hope this is clear. That's the answer. Now you can see the answers over here as well. If you're thinking, okay, see now here there is a little bit of difference, doesn't matter. Okay, now there is a huge difference, guys. I just forgot a very important thing. Please do not do the mistake I did in the exam. This is gonna be 0. Why? Because derivation of 1 is 0. I don't know what I was thinking when I was solving that. So this 1 is not there. Okay, even over here this is not there at all. Now that was a simple mistake. In this case didn't occur a lot of problems. Let's just look into the answer. You have 3y cosine x minus ey divided by, yes, that's absolutely right. Only thing what I missed was this 1 to be derived to be 0. In my case it's okay. I can write this term first and minus e to the power y, which is in the solution set, but this is also the correct answer. But if I'd missed something else over here, the left side, then it would have been a huge mistake. So this is how we solve it. And now we have okay, square root functions. I think so we have done one square root problem already. Anyways, let me do this as well. Here, it's not only square root, it's a product rule as well, isn't it? Now it gets a bit trickier. This is A, this is B. Let's use the product rule. It'll be A prime B plus A B prime. And here we will have 2y y prime times square root x plus y plus the second y square term remains as it is. And what is the derivation of the square root? It will be 1 by 2 square root x plus y. And what is the derivation of this? Derivation of x is 1 plus y is y prime. See, there is product rule, chain rule, all that, everything together, you know. So this is the solution of only this AB. Minus 2 comes down to be 8x equals y prime. Now let's try to rearrange. Now you can do one thing. What I would do is, since the denominators are not desirable generally, I'll just multiply 2 square root xy throughout. So I'll multiply this by 2 square root y. So what happens is it's 2y y prime square root x plus y. This entire thing is multiplied by, I'll write it over here. It's all multiplication. So 2 square root x plus y. Then over here, now this, if I multiply it with 2 square root x plus y, denominator numerator cancels, and you will have only the top terms. That's the numerator terms. Y squared 1 plus y prime minus 8x. Then again we have 2 square root x plus y equals, lastly we have y prime 2 square root x plus y. Even you can do it without this simplification. It's just that this fraction will remain. When it goes to the other side, it might be a little, confusing. Now then, what else? Group the y prime terms. There is one y prime here, and y prime here. What I would do over here is, first I'll rearrange it. Let's simplify how much I can, because the numbers can be multiplied. And let me do it in a little simplified form. So 2 and 2 is 4. Y. What about square root x plus y square root x plus y? If you have square root a times square root a, it's power half and half, it's a, isn't it? Now here what happens is, this term becomes x plus 1, x plus y. The square root cancels off, you get a whole term. And then lastly, I'll write the y prime term here. Plus, here there is y prime. Now this entire thing, you can see, what you can do in this case is, I'll multiply y square inside. Okay, it'll be y square plus y square y prime. This is y prime of x. This is what we are solving. I'm not sure what's there in the solution set. They may not have multiplied this. They might have. No, you have to multiply because this is y square. You have to, no matter what, you have to multiply it inside. Then minus 8 times 2 is 16. Then what do you have? 16 x square root x plus y. That is equal to y 2 times y prime square root x plus y. Now let's look into the y prime terms. First term y prime, this is also having y prime, and this is having y prime. Now instead of moving all these both to the other side, I'll just move this inside and this to the other side, because this doesn't have y prime. So that is going to look 4y times x plus y prime plus y. Okay, now this y square also moves to the other side. Sorry, I just didn't realize about this. It's only this term. So it'll be y square y prime, and this one comes inside. It's 2y prime square root x plus y. This all will be equal to what? This to the other side will be positive x square root x plus y. And this to the other side would be minus y squared. This is the answer. And now when I remove this y prime, and y prime common outside, you're getting a huge term inside. That is x plus 2x plus y squared minus 2 square root x plus y. That is equal to 16x square root x plus y minus y squared. Now the final answer over here would be this, all the terms to the other side in the denominator. 16x square root x plus y minus y squared divided by 4y times x plus y squared minus 2 square root x plus y. I hope this much is all clear for everyone. That is the final answer. Now it's very lengthy, isn't it? But see, it's all about differentiation, derivation of this using on both the sides, using the product rule, chain rule, and all the rules which are required. Then we search for the y prime terms, group them up, and just take all the remaining to the other side. So here you can see that's the answer. Now look over here, answers, it's almost same. Yeah, it's the exact same answer, right? Yeah. Okay, just a little bit of rearrangement is changed. I've not written it in the order, but that's the same answer. So this is how we solve it up, guys. And see, always remember, it's better, see over here, which I've written, to remove this denominator. When you have denominator, when you take it to the other side, it's fine. You can keep it like that. But especially over here, it would have two of these terms would have denominator. It will be messy, it will be very, not so clean as this answer. That's why. But if you are really getting confused, yes, absolutely can do that. Okay. Now then, again, we have cosine, sine, and everything. Now this is similar to, see, this cos x plus y. This x plus y is like a. Okay, it's like cos a. Don't think, okay, this is multiplied here. No, this is degree. This is entirely different. Now, what do we do over here? Product rule again. Okay. Now, if you want, you can remove this minus y squared to the other side. It'll be plus y squared, but that doesn't help us. Yeah, it's just going to be one term over here, two terms over here, but that doesn't help us at all. But if it was, like, say, divided by y, then we take this to the other side. It'll be helping us much more, That's why we, in one of the problem, we removed it to the other side. Now, this problem here, x, okay, first let me write the rule for product rule. A prime b plus ab prime. I just make it a habit. Doesn't matter, I know the rule in my mind by heart, but just write the rule. It's much easier, You will never tend to do any mistakes. Let's solve the first term. This is the first term, this is the second term. A and this is b. It'll be 1 times cosine x plus y. This is added to x into, what is the derivation of cosine? It is minus sine x plus y. Hope this is clear. Then this minus y squared derivation would be minus 2y prime equals a derivation will be 0. Now we will just rearrange how much we can. Here it will be, see, now did I miss something? Oh yeah, absolutely, I missed a very important thing, guys. What is it? Chain rule for the b term. A is x. I derived minus sine xy multiplied by what? Whatever is inside I need to derive, right? Multiply by 1, x derivative is 1, plus y prime. Then we have this minus. So this is an important term which I missed. 1 plus y prime minus 2y into y prime. So there are two y prime terms. Now this is another bracket for the sine. Now let me multiply this x inside. It will be cosine x plus y. Then over here we have minus x times sine x plus y. Okay, now see, this is a little bit tricky. What I can do is, I'll do it in two steps, okay? I've just rearranged the left side term. See this minus I've written over here with this x and this entire thing is multiplied here by 1 plus y prime, which I've still not solved, okay? I'll do it in the next step. Here it is minus y into y prime equals 0. Now, this I'm going to multiply here and here. See, this left side is entirely a single term because this minus is over here and this is a variable. So this becomes a term and then we multiply it inside. I hope this is clear. See, it's like a b prime, right? This entire thing is b prime. So we will, all things are multiplied, but there are two terms here, right? Because it's plus. But this is not two terms because this is like sine theta. It's a single angle itself. It will be for sine itself. So cosine x plus y minus, now I multiply this here, it will be x sine x plus y multiplied by 1 is the same term, but now we will have x sine x plus y, and then we will have y prime. Can you see this y prime is there? Minus 2y into y prime equals 0. Now this and this only have y prime, all the other terms over here itself. Now since these both are negative, I'm going to take these both to the other side. Cos x plus y minus x sine x plus y, that is equal to 2y y prime. This will be plus x sine x plus y and y prime. Now let me remove the y prime common out. You're going to remain with y 2y plus x sine x plus y. Okay. Then left side we will have cosine x plus y and minus x sine x plus y. Now let's take this to the other side. It will be, the numerator is the same as above, x plus y minus x sine x plus y. Entire thing is divided by, okay, it's a crooked line, but see, this entire thing will be just divided by this term 2y plus x sine x plus y. Now you can write this first and next after this you can write plus 2y as well. It's just placement doesn't matter much. As long as the answers terms are correct, that's the answer. That is all y prime. In a lengthy problem, that would be the final answer. You can see that's the thing. See over here they have written 2y later. This sign is written first. That's all right. So that's how we solve it. And two more problems to go. Let me do it quickly. Now we have natural logarithm. I hope you remember derivation of natural logarithm is 1 by x. Okay, ln x. It's called as ln x or ln x, anything. Natural logarithm is the actual term. Now let's use the rules. Derive both the sides. It'll be e to the power 4y, derivation of e to the power anything is the same term, multiplied by the chain rule, that will be 4y prime. So derivation of 4y is 4y prime minus, now derivation of natural logarithm will be 1 divided by y squared plus 3. But here, after this, whatever chain rule, you have to multiply it up, isn't it? So it will be 2y y prime because 3 will be 1. This is all equal to the right side derivation of 2x is just 2. Now, how do we simplify? We got the y prime terms already. It's pretty simple problem. Here you can just take y prime and take everything to the other side. It's fine, but can you see there's a denominator? It's not desirable to have the denominator, right? So what we will do is, let's rewrite these terms. Before we rewrite, see this all plus and minus will divide each term. So this is one term, one term, one term, right? Let's all multiply the other two terms by y squared plus 3. So here, what's going to happen? 4, I'll write it first. Power 4y, y prime. This is all multiplied by y squared plus 3. Now here you don't have to multiply because when you multiply, this denominator gets cancelled. So you're remaining with 1 times this much will be 2y y prime itself equals 2 times y squared plus 3. Now, which are the y prime terms? These two, right? I'll just take y prime here, and you're remaining with 4e4y. It's power, okay? Y squared plus 3, this is in a bracket. And then minus 2y. I'm not going to multiply this inside because anyways y prime is outside itself. I just took it out. Equals 2y squared plus 3. Now take this to the denominator of the other side. Y prime will be equal to 2 times y squared plus 3, which is a quantity together. And 4e4y, y squared plus 3 minus 2y. This is the final answer. So this is how we would solve natural logarithmic problems. You can see that's the same answer here. Sometimes, these terms might be rearranged, but as long as you have written the correct quantity, that's more than enough. And the final problem here. Okay, this is again something only exponential. We have done this before as well. Let's quickly solve it now. It's just that square root and exponential are there. Here we have to use product rule. A, this is the first term, a, b, that will be a, b, that is a prime b plus a, b prime. Now, what happens here is ex squared, that is as it is, multiplied by 2x. Why? Because when we derive the first term, e to the power x is e to the power x itself, but we have e power x squared as it is. Then we derive the chain rule, whatever is above it, whatever the power. If it was only x, we write multiplied by 1, which we don't write. It'll be just this term. Next, it'll be plus, oh no, I have to write the b term, right? See, I would have forgotten. Since I have the rule here, I can easily check with it, right? This is all a prime. B will be y plus, what is a? It is ex squared multiplied by b prime is y prime. That's it. B prime is basically y prime. Now minus, what about this side? It'll be 3 square root x derivative. What is the answer? It is 1 by 2 square root x, isn't it? So I'll just write over here divided by 2, 3 divided by, it's like 1 by 2 square root x. It's just the denominator, right? So I'll directly write it over here, y squared plus 2. But now then the chain rule, whatever is inside must be derived as well. It'll be 2y y prime, that is equal to 2x plus 0. I'm not going to write it because this constant terms are 0, derived as 0. Then here we have got prime. Here we have got prime. But before that, we have a denominator which we multiply throughout. So let me rearrange this. 2xy e to the power x squared multiplied by again 2 square root y squared plus 2. Plus again over here it is ex squared y prime multiplied by 2 square root y squared plus 2 minus, what do we have over here? It's 3 times 2, 6y y prime. Now I don't write any denominator or multiplying because when we multiply 2 square root y squared plus 2, it cancels off. That is equal to, what is at the right side? 2x multiplied by 2 square root y squared plus 2. Now then, let's look at all the y prime terms. There is y prime here. There is y prime here, right? Let's leave those two terms here, everything else to the other side. So, ex squared y prime, and this 2, I'll write it out over here. Square root y squared plus 2 minus 6y into y prime will be equal to 2 times 2 is 4x square root y squared plus 2 minus these two. Let's solve it up over here. 2 times 2 is 4 x y e to the power x squared, this is power 2, square root of y squared plus 2. I hope this much is clear. Now y prime and y prime, there were two terms which are over here, then everything else to the other side. Let me take y prime term outside. Now if you're thinking, yes, you can directly remove y prime and write this divided by the remaining parts, but I'm just doing the steps here so it's very clear. See, I will tell you after the final answer what step you can easily avoid in a minute. Now y prime is outside, so that is not there, and over here we have y power 2 plus 2 minus 6y only, y prime is taken out. 4x square root y squared plus 2 minus 4xy e to the power x square square root y square plus 2. Now let's just divide all this. It's y square plus 2 minus 4xy e to the power x power 2 y square plus 2 divided by 2 e to the power x square square root y square plus 2 minus 6y. Is that okay? And that is y prime. Now what I was saying is, from this step here, you can directly jump over here. The right side will remain the same. Now here, if you remove y prime and y prime outside, this is going to be only these two terms omitted, right? See here, 2x e power x squared square root x y squared plus 2 minus xy. You can directly write this, skipping this term. But just for understanding purpose, I've written all the details. So that would be the answer, and that's it. So over here they have, okay, now you can see one thing, there's some changes here. What is the changes? This is correct, but they have removed a common factor of 2 outside. What do I mean? There is 4 so you can remove 2 outside and you are remaining with 2x and this term minus 2xy, and this term even down you can remove 2 outside, so you're remaining with ex squared and minus 3y. So then this 2 and 2 is cancelled. But as long as it's considered, you can do that, like you can divide all the terms by 2 directly. So this will be 2, this will be 2, this will be 1, and this will be 3. You can even directly do the step directly as the answer as 2x squared and so on. See whatever is mentioned here, you can see this, that's the final answer. Or you can leave it as 4, what I've kept it, that's the same thing. It's just that it's not the simplified form. They have not asked the simplified form, it's just the y prime they want, right? But if you see these common terms like all multiples of 2, just cancel, divide all these terms by 2, and here you go, this will be the final answer. This is the end of question 18. Guys, a quick reminder, you can subscribe my channel for free. There's no cost whatsoever. If you subscribe, it will really make a lot of difference for my channel, and I really appreciate it. In this video, we will solve problems using Rolle's theorem or the mean value theorem. Here from exercise 1 to 6, we need to see whether these problems can be solved by Rolle's or the mean value theorem. But before that, you need to understand two important rules. For both Rolle's and mean theorem, first thing is the given function must be continuous at the given interval, continuous. And second one is differentiable. It must be differentiable. Okay. So these two are very important conditions. And then there is another condition for Rolle's theorem. For mean value theorem, if this condition is not met, then we do mean value theorem. But since this is in writing exam, let me write in detail. Now, if this is the given question, what do you do? Now, before we start the question, I just want to note, see, all your exercise problems are polynomials. So you are very lucky. You don't have to worry about it. All the problems given to you will meet the condition 1 and 2. Because polynomials are continuous everywhere and differentiable everywhere. So let me write it out. Here, first thing, f of x is continuous at the interval. You should write it as closed interval minus 2, comma 2. This is very important. Now, continuity means there is no breaks, it's continuous function. There is no asymptotes or no holes or no jump discontinuity, nothing like that. So that is important. Now, what about the next statement? After this line, write again, f of x is differentiable at, now always remember differentiability will be at open brackets minus 2, comma 2. So this is the thing. These two statements are very important, and when it's polynomial, always these hold good. Over here, if there are different limits, intervals, change these accordingly. These two will carry, these are like, important hypothesis, and then only you can go ahead with these two theorems. Now, next, what do you do? We need to know whether we use Rolle's theorem or mean value theorem. For Rolle's theorem, there's a condition. Now, these limits, right, these intervals, we consider them to be a and b, okay? Over here, f of A must be equal to f of B. If this condition is met, we use, if this is met or this holds good, then only we use Rolle's theorem. Otherwise, we go to mean value theorem. Let's see how does it work over here. Now, we have the given function f of x. If you want to solve for f of A, what do we do? Instead of x, we put a squared plus 1. That's it, right? But now, what is the a value? It is minus 2. So what happens here? Instead of a, I'll put minus 2, and the entire thing is squared plus 1. What is the answer? It is minus 2 the whole square is positive 4, because minus minus becomes plus. When you square it up, plus 1 will be 5. What about the next one? F of 2 only. So it'll be just 2 squared plus 1, right? Instead of x, I put 2. Over here, instead of x, it was minus 2. Again, it's the same thing. 4 plus 1 is 5. Now, here you can say f of A equals f of B. Or you can use these terms itself. Now, instead of A and B, I feel that it's better you write the interval itself. I'll write over here f of minus 2 is equal to f of positive 2. Hence, or therefore, or hence, we can use Rolle's theorem. Rolle's theorem. So this is the thing. Now these three statements are very crucial. Now after this, we can easily start solving everything. I mean, solving the Rolle's theorem. We can apply it. Now what Rolle's theorem says is, if these three conditions are met, the first, second, and third, you can write it in 3 lines. Then the derivative of this particular function at a point C will always be 0. So if these both are equal, the function will be something like this or like this, because they always come back, right? So even if it decreases, it'll come back to the original point. So you will have a slope of this given function. The tangent the tangent is 0, like the slope is 0 over here, slope of the tangent line. Even over here, you will find that, because it will come back to its original position. So that's it. Oh, now let me just remove that and let me start solving the problem over here. So what do we do? Instead of writing x, we are writing it for a value c. So what is f of c here? That would be just, instead of x, I put c to the power 2 plus 1. Now consider this as a variable and let's derive it. F dash of c would be, just imagine this was x, it would be 2x, right? But instead of x, we have c. 2c plus 1 will be 0, so I'm going to ignore that. So now what is the derivative of f dash of c? It is 2c, that is equal to 0. So what is the c value? It is 0. So this is important. So now we got the c value is 0. Whether it's within the range? Yes, it's within the range. And now they also asked you to graph it. After this much, after these 3 important lines, even this must be written. You need to graph. You can directly get the graph points from the table option in your calculator. Let's go over there now. To graph any function in calculator, you just have to press mode and then 7 for the table option to get the points. Now type the given function. It is alpha x squared plus 1. That's it. Now most of your calculators, if you have a similar calculator like this, you won't get this option. But if you have the latest model, then you will get this option. Ignore it. We have just one function to graph. I just press equal to. Where do you want to start? Now these given values are there, right? These intervals, we have to start at the lowest point, that is lowest number is minus 2, that's a value, and end it at 2. Now if you put a step of 1, what happens is you will get the points minus 2, minus 1, 0, 1, 2. That is okay, but even if you want better understanding, you can give a step of 0.5. But now I'll leave it as 1 only and I'll show you what it means. Now here, I hope you will get a graphing, coordinate plane like this, with x and y axis. So here, where is x minus 2? Somewhere over here, right? So the y value is 5. So at x minus 2, imagine this is 5, you will have 1 point here. What about this? At minus 1, you have 2. Imagine this is 2. At minus 1, this is the point, second point. At 0, it's 1. This is another point. And let's just go down here. And since it's a parabola, it's a parabolic graph, it will repeat itself over here. At 1 we will be having 2, and lastly at 2 we will have at 5. And then you just join these points, just join them carefully. That's it. That will be the answer. Now if you look carefully at c value of 0, that is x value over here 0, you can see it turns right there. It's a flat line. The slope is 0. Slope of the tangent line will be 0. So this is how we graph it roughly. You don't need to accurately graph this. This is more than enough. If you have a coordinate plane, it will be more accurate. Mine is just approximations. So you can see this is more accurate. And that's it. That's the answer. C value is 0. But see, over here they have written it in a paragraph, but I would highly recommend you to write it like this. On the left side you can write below this and write the statement f of x is continuous at -2, 2. F of x is differentiable at this particular limit. But here it's open bracket, here it's close bracket. Differentiable always will be in open bracket. Now similarly we can solve the other problems. The same concept, but I think so this is a mean value theorem problem. Let's look into it. Yeah, it'll be 0 and 2, right? It'll change. So first thing is the function f of x is continuous, okay? Continuous at 0, 2. The same statement what I've written previously, you must write it. Second, the given function is differentiable at 0, 2. This is open bracket, open bracket, small brackets you can say. And then now we will solve for f of, this is a and b. F of a, that is 0, would be 0 squared plus 1, that is 1 only. F of 2 would be, here whatever x is there you put 2 squared is 4. Let me write it, 2 squared plus 1, 4 plus 1 is 5. Do these match? They don't. So you can write over here the third statement, f of 0 is equal to 1, f of 2 is equal to 5. Therefore, or hence, we use mean value theorem. So just copy the statement over here from the question. And now what do you do? For the mean value theorem, the derivative of the c function, the c value will be given by a formula. It is like a slope formula, y2 minus y1 by x2 minus x1. Now instead of y2 we have f of b. The second point, I've just changed this over here. The same thing, the slope formula, y2 minus y1, right? F of b minus f of a divided by b minus a. This is it. Now what do you substitute? You have f of b, f of b is over here. Let's substitute directly. F dash of c would be, no, before that, I need to find f dash of c. See, now f of c is c squared plus 1. Let me differentiate this. F dash of c would be 2c plus 0. Same like the last problem, just the limits are changed. Now here what we do is, this particular 2c value is over here under f dash of c. Okay, so it's just that we will put 2c, and over here f of b would be, b is how much? 2, so that is 5 minus f of a is 0, and this is the value, 5 minus 1 divided by, what is b value? It's 2 minus 0. Let's solve it up. It's 2c is equal to 4 by 2. 2c is equal to 4 by 2 is 2. C is equal to, divide both the sides by 2 over here, and here it will get 1. So c value is 1. That is the answer. Now these two statements are very important, and the third statement determines which theorem to use, whether it's Rolle's theorem or mean value theorem. And now what we do is we just graph. Now how do we graph? Using the calculator. We had just now graphed this, but only there is a difference in the start and end point. Now what you need to first do is go to mode 7 for table method to graph to get the table of values, alpha x squared plus 1. And now when you press next, ignore this. If you're getting this, if you're not getting, well and good, you will get the start option. Start is always at the a value. Let me take 0. Now I won't end at 2 because if sorry, I have to end at 2. Sorry, this is correct. Now I won't give a step of 1 because if I give a step of 1, look over here, I just get 3 values. I mean, this is fine, but still it's not so accurate. Like, I mean, you can graph with 3 points, it's fine, you can go ahead. But what I would suggest is, for a better graph, this is the given equation. Starting is at 0, ending is at 2, and just give the step of 0.5. Now what it makes is, you will get values of 0, 0.51, 1.5, to you will get a more depth in the graph. There will be more points to plot. So then we will plot, and over here now, since we are starting at 0, it's over here and it goes up and up. That's it. That will be the graph. Okay, you need to plot it accordingly. If you have a coordinate plane, it will be much easier. Now you must only focus on the region 0 to 2. This is it, 0 to 2. And you can see in your calculators, you got these points. Now at 1, where is at 1? At 1 over here, you can see there will be a tangent line. The slope of the tangent line is 0. That's the tangent line drawn to this particular graph. So that's it. The answer of C is 1. Now one more thing, what is this line specifying? When this line is drawn, it touches only one point of this graph. At 1, there will be only one point, and everything will not touch the graph. Now if you draw a line like this, what does this mean? This is a secant line which touches more than one point. When it touches only one point, it's a tangent line. The same concept is going to be continued anymore. Now first thing, continuity at 0, 1, close brackets, 2. Now this is also polynomial, so differentiable at small bracket 0, 1. Now next, what do we do is we see whether a and b are equal. F of a is directly, I'll write 0, it will be 0 plus 0, that is 0. F of 1 will be 1 cubed plus 1 squared, that will be 1 plus 1, it's 2, because 1 to the power anything is 1 itself. Now these both are not equal, so f of a is equal to 0. You can write away directly the value is 0, f of 0, and f of 1 is equal to 2. Therefore we use these 3 dots, means it's therefore, okay? Or you can write hence. We use mean value theorem. And then what we do is we use the formula of mean value theorem. F dash of C is equal to, you should write the formula f of b minus f of a divided by b minus a. Now here let's find f of c, that is equal to c to the power 3 plus c squared. And over here we will have 3c squared plus, now over here it will be 2c. Now this is derivative of c. Now substitute this under f derivative c, 3c power 2 plus 2c, that is equal to, what is f of b? That is f of 1 is 2 minus 0 divided by 1 minus 0. It's basically 2 divided by 1. It's 2 itself. This entire thing is 2. Now let's take this 2 to the other side. It'll be 3c squared plus 2c minus 2, that is equal to 0. Now this is a quadratic term. How do we solve it is, in the calculator using mode phi 3. If you have your default mode in the calculator, then just go to mode, equations. This is the equation, it's a quadratic equation, power 2, that is mode phi and then 3. And now type in the coefficient 3, 2, minus 2. What's the answer? Now don't write this in fraction form, just press SD. Let's write in decimal forms. It'll be x is equal to 0. I'll write 2 decimal only, 55. And what about the next answer? It is negative 1.21. X is equal to negative 1.21. Now which is the correct answer? Which is within this limit? 0 and 1. It's only this is the correct answer. This should be ignored. You can, oh, it's C value, okay? So therefore C is equal to 0.55, because that is the only area of consideration for us. This is the intervals, right? So we should graph now mode 7 and write this equation, x to the power 3 plus x to the power 2. And over here starting is, this is not there, starting is at 0, ending it at 1. Now please, here you have to use the step of 0.5 and you get these values. And now you can see the graph over here, and you can even compare these values. At 0.0, the y value is also 0. See 0, 0. Now at 0.5, somewhere over here, what is the y value? It's 0.375. Yeah, that's accurate. It's somewhere over here. At 1, it's 2. Let's check. At 1, it is 2. Yes. At least 3 points are enough, because you will have points. Let me just draw it over here. From this, and this one. Okay, you get these 3 points. So you understand it's going up. So just draw a smooth curve. I mean, it's okay if it's not very accurate. You have to just try how much you can. Okay, for this case. And then at which point over here, where is the C value? It's 0.55. Somewhere over here will be the, say, 0.55 would be the tangent line. Just draw a straight line at 0.55. Graphing is important. See, after this graph, you have to draw the straight line at which point? 0.55. Don't consider negative 1.22. You should not consider this. It's only this. So this is the correct answer. Just remember what I wrote. If you just write this, it's more than enough. Everything is in detail in this. Just make sure you complete the sentence. I written properly in the first question, right? Just follow the same thing for item. Now this is again the same function, so I won't do it, only the interval values are changed. So you need to do the same 3 steps. You need to do continuous, differentiability, and then check whether f of a and b are equal. You might think, oh, it's 1 and 1, negative, will it be gone? No. F of b is, let me do b first, will be 1 cubed plus 1 squared, that is 2. But what about f of minus 1? Here will be minus 1 the whole power 3 plus minus 1 the whole squared. So what happens when you have odd power and there is negative number? It will be negative itself. Negative sign remains. When it's even number, the negative sign will be multiplied itself and will be positive. So in this, it will be minus 1 plus 1. This is 0. So here f of a would be 0. So you can see this is not equal. So we have to use mean value theorem. 2 minus 0 by 1 minus of minus 1. Why? Because this is minus and minus 1. So it's 2 divided by minus and minus becomes plus. 1 plus 1 is 2. The answer is 1. Here this is 1. But what is the derivative of this? We have done that before, right? Just make sure you make it equal to 0 and bring it inside and solve it up. You'll get the answer. See, now here the C value is 1 by third. And when you graph it up, you get this over here. We had got only so much in the last problem, but now you have other points as well. So in the graph, you will get, see, this point, you'll get this point, you'll get this point, some points, and then just join them. And look over here, 1/3 is what? 0.33. So somewhere over there, you have to draw a straight tangent line. You need to use a scale to draw the tangent line here to be accurate. Now in the last 2 problems, we have trigonometric functions. So here there are a few things you must remember. Whenever you have trigonometric function, please use radian mode. R is for radians. I'll show you how to use it in the calculator. And make sure you use calculator if you're getting confused. Directly pi by 2, everything is available in calculator. Okay. If you memorize the values, it's well and good, but double check using calculator for everything. Now it's the same thing. It's just that this is a little bit different. First step is what? Continuity at, here open bracket 0 comma pi by 2. What is pi by 2? How much degrees is this? Pi is 180 degrees, pi by 2 is 90 degrees. Second is differentiable. When it's differentiable, this will be open small brackets 0 comma pi by 2. That's it. And what about this over here? Third one, we need to find f of a and f of b. Let us solve whether they both are equal or no. So f of a is 0, sine 0 is always 0, sine 0 is 0. What about sine pi by 2? Sine pi by 2 is, sine 90 is 1, so sine pi by 2 is 1. But I'll just use the calculator to show you how exactly you get these values. Let's take our calculators now. Here first, few things. Let's just clear our calculator. Shift 9 3 equal and AC. That's cleared. Now always a default mode of a calculator will be in degrees. How to make it in radian? Whenever you see trigonometric functions, use radian. That is by pressing shift and mode. And then the option number 4, rad is radians. Now you can see r is over here, so now it's in radian. Now sine, if you have anything in pi, you have to make it in radian. If it is in degrees, you just keep in degree, shift mode and 3, but now we have in pi, so it's shift and pi here. Don't write 3.1 for shift and pi is very important, right? Divided by 2, and then just close the bracket. What is this? It's 1. So this is how we do it. If it was cos, it'll be 0. Cos pi by 2, 0. So that's how we get it. Okay. Now this is how we check both the values, and now we know f of 0 is 0 and f of pi by 2 is basically 1. Therefore, we use mean value theorem. Now then, let's write the formula. F dash of c will be equal to f of b minus f of a divided by b minus a. What is f of c here? F of c is sine c. Let's derive it. F dash of c or f prime of c will be cosine c. Now don't put a negative sign because sine derivative is just cosine. That's it. And this is the answer. Now let's write over here f derivative is cosine c, that is equal to, what is f of b? F of b, it's 1 minus f of a was 0 divided by b is pi by 2 minus 0. Let's rearrange. Cos c is 1 divided by pi by 2. So now what does this become? Yeah, 1, this again pi divided by 2. So when we rearrange this, this goes up, isn't it? Now here, look, this is 1 divided by, there's a fraction. It's like this pi by 2 is a fraction here. So this goes up over here in the numerator. So it'll be 2 by pi basically. So when you simplify this, it's going to be 2 by pi, or you can leave it like this because you're going to use calculator. So anyways, the answer will be same. C will be cos inverse of any of this. It'll be 2 by pi. So let us use a calculator and check the answer. In order to get the inverse function, you need to press shift and cosine. It'll be cos inverse. So first I'll use this 1 divided by pi by 2. That is shift pi divided by 2. You can write everything as it is and the answer will be 0.88. Now I'll just change this over here and I will write it's pi, and over here what do we have? About 2. It should be 0.88. That's the same answer. So anyhow you do, you will get the answer. Now this is the solution. You can see the final answer C will be 0.88. Now how do you graph? Graphing is simple. Just use the calculator again, mode 7. We press mode 7 and then type the function sine alpha x, close the bracket. Remember, it must be in radian mode, and it is in radian mode. Let's start at 0. Let's end at pi by 2. Okay, it's pi, shift and pi. Now the fraction symbol will be like this, or you can write divided by, it's the same thing, divided by 2. And what is the step you want? Now don't take step of 1, 2, 3. You should take in terms of pi. So 0 to pi by 2, it's 90 degree. I would take like something 30 degrees, 0, 30, 60, pi 90. So 30 is basically pi by 6. I'll just divide this by 3. There is a way to easily solve this. Whenever you have 0 and then you have pi by something, pi by 2, right? If you want, say, 3 points over here, just divide both by 3. It will be 0 to pi by 6. I mean, just this value you should just divide by 3. So you put the step pi by 6, you'll get 3 points in between 0 and pi by 6. So let me put shift pi divided by 6, and now you will get 3 points, that is over here, these. Now remember, 3 points in between. See, after 0, 1, 2, 3, and this is the ending point. Okay. Now remember one important thing. You will not have in terms of pi, you will have the value. Now what does this 1.5707 mean? This means it's pi by 2, the ending value. Pi by 2 is pi 3.14 divided by 2. This is the value. Now what this means, it's all pi divided by certain values. Now here, if you analyze carefully, this is 0, pi by 3, pi by 4, pi by 6, pi by 2, and so on. Pi by 6, pi by 4, and pi by 2. So you need to analyze this thoroughly, and then even if you don't understand them, it's fine. Just put this x value and y value. Let's look over here in the graph. You can see this. Where is the 0? At 0, it's 0. So this is the graph. And then at 0.52, where is 0? Somewhere over here. What is the value? 0.5. So at 0, so can you see it corresponds? You need to plot the point. That's it. At 1.04, where is over here somewhere? You need to have 0.866. Yes, that is approximately correct. Yeah. Obviously it's accurate only, and 1.57 would be the last point at 1. So then you just draw, and what is the value you will have? The c value, the tangent line at 0.88, right? Where is 0 point somewhere over here? There'll be a tangent line for the graph. So this is how you solve it up. Now again over here it's the same graph, but it's negative pi and 0. I guess it's Rolle's theorem over here, because pi is again 0, sine 0 0. Yeah. So here you have negative pi and 0. Only thing is, this is going to be Rolle's theorem. See, the f of pi minus pi and f of 0 will match. Let me show you how this is exactly done. See, step 1 is continuous. You should write this is continuous. Step 2 is differentiable. These are very important statements. Next one, we will do f of minus pi equals sine negative pi. Sine pi or negative pi will be 0. What about f of 0? Sine 0 is 0. Since, third statement, f of minus pi is equal to f of 0 is equal to 0, we use Rolle's theorem. So this is important. And then now Rolle's theorem is the most simplest one. F prime of c is equal to 0. That's it. Derive this function. F of c first. Write this. It's important because it's writing exam. You need to write everything in detail. Sine c. Then what is f prime of c? Just derive the above function. It will be cosine c. So now cosine c would be equal to 0. Now take cosine to the other side. C would be cosine inverse of 0, and just put in the calculator. Cosine inverse of when is, see now this, the way to understand is, when will cos function be equal to 0? Cos function is always equal to 0 when it's at 90 degrees, right? So yeah, at 90 degrees it's 0. So the answer over here would be c is equal to cos inverse would be pi by 2 or 90 degrees. And if you can do it in the calculator, you will get that answer. Okay, it's pi by 2. Now here I forgot one important thing, guys. Now this can be easily obtained in calculator, but if you're thinking how exactly, now if you know the cosine function, what happens? It starts from up, right? It goes over here, it comes down, it goes up like this, right? So this is the function, and now at the left side also it happens the same thing. Okay, when does it touch 0? When is it 0 over here? At cosine 0 it's 1. When the y value is 0 is at pi by 2. Here pi by 2, and here it's minus pi by 2. Since we are dealing with the limit of minus pi from year to year only, which value does it touch 0? It will be at minus pi. So we have to take negative here. Now if you put it in the calculator, cosine inverse 0 is pi by 2. But look, just add the negative sign because we are going towards the left axis. Is that clear? From 0, negative pi by 2, minus pi. That's why this is the interval given to us. Therefore, we take pi by 2. Okay. Right side will be pi by 2. Yes, it will touch 0 over here. But we are taking the left side value. That will be negative pi by 2. That's the only difference. So that's an important, crucial thing. And then you know how to graph from mode 7 in the table. You get the points and graph it up. And here you can see it, minus pi by 2 is about negative 1.57. There's a tangent line. So this is how we solve the question number 19, which is about Rolle's and mean value theorem. And that's the end of this question. See you soon in the last writing question. We finally moved to the last question in the writing part, the question number 20. It is to use L'Hopital's rule to compute limits in various cases. This term here, L'Hopital, right? It's pronounced as L'Hopital or El Hospital because it was written as El Hospital. This particular spelling, when you convert it to English, it means El Hospital. But then, the French writings changed, and then they changed this words to O and this, and they pronounce it as l'hôpital. If you have heard it as L hospital, it's the same thing, because back then it was written just like this. Now I'll be using it as l'hôpital, and look at these problems. Now L'Hopital's rule basically revolves problems along the indeterminate form. Indeterminate form is something like 0 divided by 0, or infinity divided by infinity, or you can say 1 to the power infinity, okay, and then 0 to the power infinity, or infinity to the power 0. All these are indeterminate forms, and then 0 multiplied by infinity, so whenever we get such forms, it's indeterminate form, nothing else. If it is, say, minus infinity, no, this is a limit. If it is infinity, it's a limit. 0 is a limit. 1 is a limit. Minus 5 directly limit. E to the power of minus 5 limit. So only when we get such forms, we can use L'Hopital's rule, provided there is a condition. It must be as a fraction like this, 0, 0, or infinity, infinity. It must be in this form, not in this. If we are in this, we have to convert it to this form. Anyways, we'll look into the problems. They're not very straightforward. You should know exactly how the method is, but starting problems are pretty simple. Limit at 0 positive side. Why is this 0 plus? Because what is ln of minus 1? Say, imagine minus 1. It doesn't exist. Or minus 0.0001. It doesn't exist. I will show you. It's better to use a calculator and check this. Here, let me take ln minus 0.0001. It's a very small, it's almost 0, but it's from the negative side. It's a math error because it's undefined. Why? Because if you look into the graph of natural logarithm, it starts like this. It's an asymptote at 0, and then it keeps on going. So that is the reason. Now, what about root x? Root x, you can have anything. That's fine. Sorry, again, not minus values. Let's try. Square root over here, negative 0.001. Do we get an answer? Math error, because we cannot have negative inside the square root, isn't it? You can have it outside. So that is the reason why you have 0 x tending towards 0, but from the positive side. Now, do we need L'Hopital's rule here? Let us first always apply the limit and check. I'll directly apply 0 and ln 0. Now, what happens here? Here, when you start applying 0, it's 0 on the numerator. What is ln 0? You can just check it. ln 0 is basically, you will get undefined. Why? Because there's an asymptote, isn't it? But from the positive side, what happens? 0.001. It is a minus. Now, if you increase this, what happens? 0.00001. You're getting what? If you keep on increasing this, you will understand the limit towards 0 from the positive side for ln is minus infinity. How do you know that? Okay, that's a crooked line, but still, it's asymptote, right? At 0, it goes where exactly? It's going towards minus infinity. So the value over here will be 0 divided by minus infinity. Is this indeterminate form? 0 divided by anything is literally 0. So directly you can tell the answer is 0 here. The final answer would be 0. Why? Because the numerator is 0, whereas the denominator goes to minus infinity. So answer is 0 directly. You can tell it. There's one more thing you can keep in mind. Whenever you have ln, that is natural logarithm, infinity, or ln 0, from the positive side, obviously the limit will be towards from the positive side when it's 0. Here you need to understand this is if ln is, it'll be like this. I'll write the proper question and then I'll show you. Is limit x tends to infinity, okay, ln x, what will be the answer? That means you're applying x as infinity. It goes towards infinity along the x-axis, right? If you see the ln scale, it goes slowly and eventually it will reach infinity. So limit, when you apply the limit, after applying the limit, it will be ln infinity. This would be infinity, but it goes at a very, very, very slow rate, okay? So this is very important thing. Why? Because imagine you have ln x minus x. Okay, just in case you have this term, and the limit is going towards x is infinity. Now here, yes, this ln also reaches infinity, then minus infinity, right? Both will be infinity. But look here, this reaches at a very, very slow rate, whereas this is more dominant. So you can directly tell the limit would be minus infinity. Though it's indeterminate form, you can tell it. But I will show you the writing method in the coming problems. So I'm just still trying to make you understand that whenever you have natural logarithm, it will go towards infinity, but at a very, very slow rate. Okay. So the other value, if there is another infinity, that will dominate it. That's the thing. If you have x minus ln x, yes, this both goes to infinity minus infinity, but the answer over here would be just infinity. Why? Because x reaches at a dominating rate, whereas ln x reaches very at slow rate. Okay. Now these are all the things which you should understand from these functions. Okay, because that will really help in the coming problems to analyze these problems. And since it's writing, you have to write it. Now one more thing before I move ahead. There is a direct way to check your answer in this. So it's square root x divided by natural logarithm x, isn't it? Close the bracket. If you want to check any limit, all you do is calculate it at that particular point. It's not 0, but you should take 0.00001 close to it. What is the answer? Here you can see it is negative 6 and minus 8. That would mean 10 to the power minus 6 is 0.12345. Then you are 5. This minus 4. Now, if I increase the number of zeros, you can see the number of 0.00, it goes more. If I calculate at zero point 0, say I'm just increasing the number of zeros, what's happening? It became 7 zeros instead of 4 here. And so on. So that means it's going towards 0. So the limit over here, as we apply 0 from the positive side, it becomes 0. Whereas if you calculate it at 0, you get a math error. You can't. So you should take 0.001 and so on. Now let's go to the next problem. Here, can we directly apply infinity? Let's try applying infinity here and here. These are the two terms, right? When we apply the square root, infinity square plus 1 minus infinity, what happens? The square root of, it's just infinity minus infinity. This is indeterminate form, IF. Indeterminate form means you cannot solve this. But now if we rearrange this and write it as fractions, like 0, 0 or infinity, infinity, then we can solve it by L'Hopital's rule. I've not yet told what exactly is L'Hopital's rule. Let me just tell you one thing. Imagine you have two terms, okay? X squared and divided by x. Now, if you rearrange and write this, now since here, if you have limit as x goes to infinity, right? This is in the form of infinity by infinity, which is indeterminate form. What you can do is, L'Hopital told you can derive these individually. You can derive the numerator, that will be 2x, and the denominator, and now apply the limit. Now let's apply the limit. If x is going towards infinity, what is the limit? To infinity, right? So it will be infinity. So this would be the answer for the given function as well, because given function we cannot apply limit of infinity. It will be in indeterminate form. That is, we cannot determine what it is. But in such cases, derive the numerator and denominator separately and then apply the limit, and whatever limit you get will be valid for this as well. That is what he had done by proving. So that is what L'Hopital's rule means. But now we have a condition, it must be in such form only. Any indeterminate form must be rearranged and written like this. But now, here we have square root minus x, and it is my infinity minus infinity indeterminate form here. So if you're writing in the exam, you can start with writing like this. There are specific problems. When you look at them, you need to do certain methods. Now this one, what you need to do is basically, let's start by conjugate. Whenever you see square root, you need to use conjugate. What does conjugate mean? I'll just focus over here. Limit as it is, this will be written similarly till we can get non-indeterminate form, in the sense proper forms. Now here, this is in the numerator, square root x squared plus 1 minus x, right? This will be multiplied with square root x squared plus 1 and x, but the sign will change as plus, divided by again x squared plus 1 plus x. Now then we can easily solve this up, right? In the numerator, what happens? The square root, see, it is like this term considered to be a minus b, then we have a plus b. What is the formula for this? It's a squared minus b squared. So whatever this is there, the square root and square root will be whole squared. That will be square, right? It will be square root x squared plus 1 the whole square. So this square root and square cancels and you're remaining only with this minus x squared. So that is from the rule. Whenever you see the conjugate of square roots, the first term is the same, right? Just write it without square root, minus x, and x will be with square, divided by, what is this? Let's write it out. X squared plus 1. Okay, that is it. Then separately x. Okay, that this x is outside the square root, so don't write it inside. Now, why did we do this is because you can see this is cancelled off. X squared and x squared is gone. The limit still remains. Limit as x tends to infinity. But now what happens is when we apply the limit, we will have 1 divided by whatever the limit is, right? So this helps us a lot. Let me show you how. I'll apply the limit. Applying the limit. So when we apply the limit here, it seems 1 is a constant. Nothing happens. No changes. What about the square root infinity squared plus 1 plus infinity? This is basically 1 by infinity, isn't it? So 1 by infinity plus infinity is basically infinity itself. What is 1 by infinity? That's 0. Why it's 0? Because 1 divided by infinity is a big number. When you divide something by a very huge number, it tends to become a small number, that is 0. Or if you have like this 1 by 0, this is infinity basically, because you're dividing by a small number that will be a huge large number. We consider it to be infinity. So now for this particular problem, this is your answer. It's just this first step, second step applying limit, that's it, rearranging. If you write so much, it's enough. That'll be full marks. Let's just look into what they have written over here. They've not written it properly, but I would highly suggest you to write all this what I've written. Even at the question, you can just see this is not equal to, don't write equal to this. You can just write like this, corresponding, okay? This is indeterminate form. If you're thinking how to write it in full words, that would be indeterminate form. Okay, all you just do is write so much, and this formula you do not need to write. This is just a basic one. You should know it by now many times. So what I written over here is plenty. I would ask you to write this below it. Okay, it will be like this, 1 by infinity, and lastly it is 0. That is the answer. So this is equal to 0. You don't need to write it horizontal wise, just write it vertically, one below the other. So that is how we solve this problem. I hope it is clear. Now let's move on to the next problem. And this problem is what I mentioned a while ago. Now if you apply the limits as infinity over here, what happens? So it'll be infinity, ln infinity, minus infinity. Okay, this ln infinity will obviously go to infinity, but it will take a very, very long time compared to the x. X will directly go to infinity. Let me show you why. So let us take our calculators here. Let me take ln x, okay, and I will calculate it at, let me take 10 nines, 1 2 3 4 5 6 7 8 9 10. Let me take 15, 1 2 3 4 5. Okay, there's 15 nines. The answer is 34.53. Now what is the other term? It's just x, okay, alpha x, and let me calculate. It's already there, right? That same value I'm going to calculate it at. You can see it is trillion and then this thousand, such a huge number, because when you take the same, even if I take less than that, it's so much more than 34. So what happens is this infinity is dominating the other one. So this is just dominating and this takes its own time, and this minus infinity is there, so you can just ignore this part. The answer is directly minus infinity. This is by reasoning. Now, if you have reasoned this properly and written it like that in words, I think so you will get full, you should get full marks because you have understood it thoroughly and you're telling why you're doing it. But what I would tell you is to be on the safe side, let's do the method. Let me show you in methods how it can be done. So I would write this corresponding single and then a symbol and write infinity minus infinity. This is indeterminate form. You should write in full words, but I'm just writing IF, that is indeterminate form. Next then, here, how can we begin with? So you have this limit as x tends to infinity. Now there are different methods for different problem, but whenever you see this particular problem, right, ln x, now this is in infinity minus infinity. It is not as infinity divided by infinity, okay? We can't directly derive above and denominator term. Why? Because it's not in this form, it is in the infinity minus infinity. We can't directly apply L'Hopital's rule here. So what can you do? Now there is an easy way to solve it. Whenever you see ln x minus x or x minus ln x, take an x common outside. Let's remove something outside. Why? Because now what do I have? It is ln x divided by x minus 1. Let me tell you what this means. See, whenever I took this x term outside, there is nothing. So basically, I'll multiply and divide by one x term, and this term is gone out, so I'm remaining with ln x. So I'm just balancing it off. This, if I cancel it's 1, it's the same thing, it's fine. So that is what I did. I just balanced it off. And now over here, right, ln x by x minus 1. Why? Because x is removed outside. Why did I do this? Now what happens is I got this x as a single value, and there is also one other important term. What is that important term? Here I can use L'Hopital's rule. It is in terms of this, isn't it? Ln x is infinity divided by infinity. So let us now only focus at this point, and I will tell you what will be the answer. Ln infinity, you can write this at the side, don't write it just below it, okay? You can write it's fine, but now this is in terms of infinity by infinity, and apply L'Hopital's rule, okay? We just write L means L'Hopital's rule is applied. So what happens here is ln x, what is the derivative of ln x? It's 1 by x divided by, what is the derivative of x? So this is ln x divided by x, okay? Limit as x tends to infinity. So only this part we are deriving. Ln x is 1 by x above, separately, and down. What is derivative of x? It is 1. So this is the numerator. This one is the denominator. I hope that's clear. So basically what we are remaining with is 1 by x. That's it. Now let us apply the limit. So limit is x tending towards infinity. Let me apply limit over here. So 1 by infinity is equal to 0, right? So what happens here exactly? If I apply the limit, let me applying limits. You will get infinity, and over here it will be 0 minus 1. Are you getting this? What just happened? I have done this L'Hopital's rule just for this. Why I did it separately is, why I would suggest you do at the right is because we're not doing for the entire thing. Entire thing is not in this form. Only this particular term, ln x by x, is in infinity by infinity form. Then we can use L'Hopital's rule, okay? This L'Hopital's rule means derive the above and below term, and therefore we get 0. So now here, x, when you apply infinity, is infinity only. Now this term we saw over here, because of L'Hopital's rule, it becomes 0. Another way to analyze this, I'll show you how. ln x, when it goes to infinity, and x goes to infinity, which goes in a higher rate? This goes very, very slowly, whereas this dominates. So what happens is it will be basically by infinity. This is going to be by infinity. This will just be a number, constant, okay? So any constant divided by infinity is 0. This is another way to understand, because x will be infinity at a very quicker rate. So you can directly take it as 0 instead of doing this. But I would suggest you to do all this because you have understood it thoroughly by applying L'Hopital's rule. Now then, ln x by x is 0 minus 1. So what is the answer? This is basically infinity times minus 1, that is minus infinity. So the answer for this would be minus infinity. That is it. But these are the steps you have to write. Okay, these are the steps, very important steps. So, and over here also, you don't need to write this one, but this would be highly encouraged to write, because over here, when we, for these two terms, when you apply infinity, it becomes an indeterminate form of infinity divided by infinity. So applying L'Hopital's rule, we just apply infinity in both, derive both the cases, above and below, not by quotient rule. Remember, not by quotient rule. If we had 2x square by x, we don't, now x plus 2. Don't use the quotient rule. A by b, this b square, a derivative b minus ab derivative. This is not used because L'Hopital's rule tells above terms separate, below terms separate. So ln x derivative is 1 by x derivative is 1. I did it separately and then I applied the limit. That's how we go to solve this problem. And here, guys, the answer is directly mentioned. It's minus infinity. Now they have just told the numerator goes to minus 1. Okay, whatever method is done over here, you can follow the same method, but just the method which I did is much easier, I believe. Okay, now I'll tell you what they have done over here. They have taken this as divided by, but then you have to derive a long procedure, I think. So this is much easier, okay? We will do the method which they specified here in some time. In some problems, we will do this in the coming problems, okay? But whenever you have ln x minus x or x minus ln x, please do the method which I told, which is much easier compared to others. Now let's do the next problem here. Now this form again is indeterminate form. Why? If I start applying infinity, what happens? 1 plus 1 by infinity, the whole power infinity, right? So here 1 by infinity is 0. 1 plus 0, the whole power infinity, is basically 1 power infinity. Now this is again indeterminate form. Okay, by applying infinity, it's indeterminate form. How do we solve such problems? Whenever you see 1 power infinity, please follow this method, the same method throughout, which I'm going to tell you now. What is that method? So ignore the limit for some time. Let's just consider the given term. That we are going to take it as y. Okay, y equals 1 plus 1 by x, the whole power x. Now it's very crucial for us to get this down. How can we get it down? That can we, this power, we need to resolve it, because we cannot apply L'Hopital's rule in such cases. L'Hopital's rule can be applied by infinity infinity or 0 by 0. Then we can apply L'Hopital's rule L. Now here, if we take natural logarithm L ln y, or natural logarithm y ln, will be equal to ln 1 plus 1 by x, the whole power x. Now for this first problem, I'll do all these steps, but later on I'll directly write this and all. See, now here what happened is ln x. Imagine I have some power a. That is equal to, this comes down, isn't it? That's the rule of natural logarithm or logarithm functions. A can be multiplied, because when you multiply a ln x, or if you take a to the power, it's the same thing. That is the rule. That is why we are multiplying both the sides by natural logarithm. So we can bring ln over here, this x down, ln 1 plus 1 by x. Now this is very crucial. Why? Because now we can write this as denominator. We'll write this in a minute. But before that, what is missing here now? This is okay. But we have not written the limit. Let's take limit on both the sides. Limit as x tends to infinity for natural logarithm y. That is equal to, over here also, limit as x tends to infinity for this particular problem, ln 1 plus 1 by x. But here, when you apply x as the limit for y, what happens? Nothing happens. It's going to be ln y itself. Okay, there's no changes whatsoever. Only at the right side there is x term, so it will change. Now imagine you have limit of 0, x of 0, for 3. What is the answer? It's 3 itself. It's like a constant. There is no x term. If it was 3x, you multiply 3 times 0 and then it becomes 3. But here, what happens? There is no x term, so it's very easy. It will remain the same thing, isn't it? So that's why limit only will sustain at the right side, because there is x. Now, how would we simplify this? We need as fraction. So I'll just write the answer here. It will be ln 1 plus 1 by x divided by 1 by x. Can anyone tell me why? The reason is, if I have, say, multiply a, now this ln1 entire thing, I'm going to take it as x. Is that okay? Sorry, let me take other way around. This entire thing, I'll take it as a. Okay, that is ln x plus 1 plus 1 by x. And I have x here. That is x over here multiplied to it. This is equal to what? Is it a divided by x? No, you can't write, because this is multiplication, this is division. That's absolutely wrong. But this is equal to 1 by x. Why? Because if you have any term multiplied, it can always be divided by its fraction. I mean, by its inverse, basically 1 by x. That's absolutely right. This here is true. Or you can consider this to be minus 1, but it's better for us to write it as 1 by x. Okay? This is absolutely true, because this will come up. This is equal to a into x by 1, or it is ax, or x by a, x multiplied by a. So this is absolutely true. Why did we do this? Now, there is always limit, guys. If I don't write, don't forget it. You guys don't forget it. There's always this limit term here as well. It continues. Still, we apply the limit. Now, why is this important? Because now when we apply the limit, let's apply the limits. And then this becomes how much? 1 and 0. Okay. This is 1 plus 0. What is ln to the ln1? ln1 is 0 basically. Why? You can just check in the calculator. Natural logarithm of 1 is 0. And then what about 1 divided by x? So 1 divided by x is 1 by infinity. 1 by infinity is again 0. This is an indeterminate form. And you can apply L'Hopital's rule for this. Apply L'Hopital's rule. What happens over here? We had 1 to the power infinity, but we know we cannot apply L'Hopital's rule in case of 1 power infinity. We should get infinity by infinity or 0 by 0. Now we just rearrange. All such problems have to be done by this method. When we rearranged, what happens is, when we apply now infinity, it's in the form of 0 divided by 0. Now we can apply the L'Hopital's rule. Let's continue. I would ask you all to write so much, because I need to clear off some space. If you're finished writing, you can just pause the video and write it out. I'll take this off. These are a few basic rules. This is also one of the important rule which you applied, and this one as well. And now I'll write it over here in the second part. So let me just change the color. So here, when we apply L'Hopital's rule, we have to derive the numerator and the denominator. What happens when we derive this numerator? This is gonna be derivation of ln x d by dx is equal to 1 by x, right? But instead of x, we have all this term, but still it's fine. Now limit is carried on. Limit x tends to infinity. Now we need to derive above and below term and then apply the limit. So 1 divided by, what is this term? 1 plus 1 by x. Is that okay? But it's not over. If it was ln x, it's 1 by x. What if it was x squared? It'll be 1 by x squared multiplied by 2x. Why? Because we have to derive whatever x squared is also there. So we derive this term now. What is this term derivation? 1 derivation is 0. 0, I'll just not write it. But what is derivation of 1 by x? So derivation of 1 by x d by dx is minus 1 by x squared. I hope you remember, because x comes up, it'll be negative power, negative 1, and minus 2, then we take it down, it'll be positive 2. So I'll directly write it as 1 by minus 1 by x squared. This entire thing divided by this denominator term. See, this is numerator, numerator. Denominator, now we'll write denominator. What is the derivation of 1 by x? We just now wrote, right? Minus 1 by x squared. So this and this completely cancels off, and you're remaining with only x tends to infinity, 1 divided by 1 plus 1 by x. Is that okay? So it's simplified here. Now can we apply the limit? Yes, absolutely, because we have plus 1 divided by x. Whatever happens, you can just easily apply and you'll get the answer. There is no other x term. It is not going to be indeterminate form. Let me show you. Apply the limit. Applying the limit. Here then, it'll be 1 divided by 1 plus 1 by infinity. And let me just solve this up. 1 divided by 1. 1 by infinity is 0. So it's 1 by 1. Answer is 1. So whatever the limit at infinity would be, 1. So that's it. Oh, sorry, it's not over. I'm so sorry, guys. We got answer of 1. Very good. But what is 1? The limit, see this one, ln, right? We applied ln and we did it. See, can you see that 1 divided by y? Why did we do that? Because we wanted to write in fractions. Now this over here is solved with limits, okay? So this over here with limits was solved. Okay, this practically, I'll just write over here also the limit as x tends to infinity, because if you put x tends to infinity, it doesn't matter, right? This here is solved. So whatever this answer at the right side, we solved it, right? From here, see, here we solved it. That is equal to what at the left side? Ln y is equal to 1. This is very important. It's not the final answer. The answer of limit is not 1. This is not 1. Ln y is 1. But y we need, because we just applied, see, this is considered to be y, right? So we need to solve this up. What is y? Now, how do you remove this natural logarithm? Take its inverse. Exponential e ln y is equal to e to the power 1. This cancels. You will have y is equal to e to the power 1. This is your final answer. The limit over here is e power 1. Now, what happened over here? If you have ln x, okay, all you do is, and over here you have 1. If you can just do this, ln to the other side would mean x is equal to e to the power 1 directly. In the other questions and all, in the next questions, you don't need to do this step. If you have ln, say 2 here, directly y will be e to the power 2. That's it. E to the power 1 is e itself. So this would be the final answer. We can check this in the calculator. All you need to do is write the given question. It's 1 plus 1 divided by alpha x, close the bracket here, and to the power x. And what do we do is calc at infinity is a big number. I'll just write few nines. You can see it's 2.71828. What does that mean? That is the Euler's number e. Shift e to the power 1 is 2.71828. So that is the answer. It's a bit lengthy, but these are all the important steps which you must do. You do not need to write what I've written. Oh, this is that's fine. This is important, whatever I've written over here, right? So if you write so much, you'll get full marks, and this might be for 8 or 10 marks because these are lengthy problems. Okay, let's move on to the next one. See, the answer is E only. Now I'm sure they have not done all the steps. The actual steps would be this. Okay, this is like in detail I've done all the steps here as well. Now when we apply, what's gonna happen? What is the degree over here? 1, degree here 1. What happens when you have degree 1 and you're taking to infinity? You should just look into the coefficients. It'll be 1 and 1, so 1 will be the answer here when we apply infinity. And what about this? To the power infinity. Why? Because infinity x squared, infinity square is infinity, minus infinity also infinity, root of that is infinity. So again, it's indeterminate form. Okay, what is the indeterminate form? 1 by infinity. I'll just write over here. Now if you're thinking how this term became 1, imagine you have x squared minus 2 divided by 3x squared plus 5, and the limit is towards infinity. See, the 2 degree in the numerator and denominator is equal, isn't it? In such cases, you do not need to apply everywhere infinity and check. All you can do is, see the first term. What is the first term? It's 1, the coefficient, divided by 3. That is the answer. I'll show it to you. Let's take our calculators and prove this up. Here I'll type this out. It's x squared minus 2 divided by 3x squared plus 5. And here calculated at infinity, that is a big number. What is it? 0.333. It's 1 by 3. Even over here, you can just write this up only for this part, inside part. If you're wondering how I got 1, it's x plus 1 divided by x minus 2. And now what do you do? The power, here it is. No, you don't have to put the power. I'm sorry. Why? Because I'm just checking for the term within over here, the base only, calculated at many nines. The answer is 1. Okay, now if you want to check what is over here, you can check it by the calculator as well. You'll get infinity. So now then, if this was the form, what did I tell you? You must take y. I'll directly write over here ln y will be equal to this power c, because it's the same steps what I done in the last problem. Starting will be same. You have to take this as y, take the ln on both the sides, that's natural logarithm, and then you need to solve. I'll directly take it. And over here limit x tends to infinity. This whatever is the power will come down because ln is there. So I'll have square root x square minus 4. When we solve this, remove this magnitude. It's just that we have to take only positive inside this. That's fine. And over here, what we do, because it's infinite, it'll be positive. It's fine. Ln x plus 1 divided by x minus 2. I hope this much is clear from the last steps. I directly brought this power down and did it. If you're getting confused, just go to the beginning of the question 33 and we have done this. Now I will start solving it. Here, this is the numerator. So let me write first limit as x tends to infinity. The numerator will be as it is ln x plus 1 divided by x minus 2. This much is done. This entire term we will write 1 divided by square root x square minus 4. Okay. Now if you apply the limit, what's going to happen? Here it is 1 by 1. ln 1 is 0. It would be 0 here. What about this? 1 divided by infinity is again 0. It's indeterminate form. So I can use L'Hopital's rule. Applying L'Hopital's rule. Okay, L rule I'll just write. This is L'Hopital. It'll be given in the question, I believe. And now what happens is you have to derive these. Now what is the derivation of ln a by b? Now imagine a by b was in terms of two x's, okay? Like instead of x plus 1, I'm writing a and b. The answer would be b by a. Then you need to derive this altogether, multiplied by, what is the derivation of ab? It is a quotient rule. B square will be a derivative b minus a b derivative, or prime. So this is the term. When you have two terms a and b, provided that function of x, it's solvable, you need to write first b by a. Why? Because it'll be 1 by a by b, right? This, when you bring it up, this comes up over here. It'll be b by a. So that's why I've written it directly. I hope that's clear. And then what else? Whatever is these two terms, you need to derive them as well, right? That time you'll get the derivative rule. So let me solve this up, above term. So here first, when I write this 1 by 2, this denominator comes up. See, now I'll write the numerator, denominator, okay? Let me just change the color over here. So this one will be for numerator, that will be x minus 2 divided by x plus 1. That is just flipping these two. Then I'll have to multiply it with what? With the derivative quotient rule. Whatever is the denominator, you square it up. X minus 2, 2 times square. What about the numerator? What is the derivative of a? Derivative of x plus 1 is 1. Same, 1 only, okay? 1 multiplied by anything will be the same thing. What is over here? B term, I have to write it as it is, x minus 2. Minus, what about above term, a? Write it out as it is, x plus 1. And then, when you derive the b term, it's going to be 1. So I'm not going to write it. Just multiply by 1, it remains the same. So that is the numerator. What about the denominator? How can we derive this? Now, see this square, it's 1 by square root x. So what do we do is, we bring this up. Basically, what's the power of root? It is half, isn't it? This is half. So we can get it as negative half, x to the power minus half directly. So I will write this over here as, instead of 1 by square root x square minus 4, I should have done it before, and then I should apply the derivative on both this numerator, and then it would have been, instead of half, it will be x square minus 4 whole power minus half. I hope this is clear. This entire term becomes minus half. Why? Because 1 by square root is whole power half. When we bring it up, it becomes minus half. So that is the term here. This is the term. But now I will directly derive this term. Derivation of x power minus half, what happens? It'll be negative half, and then you have x half minus 1 would be minus 3 by 2 or 1.5. So here what I'll write is basically, I'll just write it over here. It'll be minus half multiplied by x square minus 4 the whole power negative 3 by 2. Here there is a very important thing not to forget. After this, you need to even derive what is inside, isn't it? Now, if you're deriving x to the power minus half, it's just this. But if it was something else, if it was 2x or something, you have to multiply even that term. Say now, this is done. This x squared derivation is 2x. It's the chain rule what we do. So now here you can see there are things that cancel. This 2 and 2 cancels off. What about in the numerator? If you look carefully, this 2 is there, right? Power 2 cancels off with this term here. That cancels off completely. And now we have, this is the denominator. Now we have to write what is remaining. Let me write it down here. In the above term, see this minus, right, is multiplied inside distributive property. So it becomes x minus 2 minus x minus 1 divided by, what are the two terms remaining? X plus 1, x minus 2. I hope this much is clear. And then what do we have here exactly? Here we have only this, don't write this n and d, this is numerator and denominator, that's it. Divided by minus, the numbers are cancelled, so only x is remaining here, divided by, what is this? Sorry, nothing is down, only above it's this. Sorry, let me just, there is no down term because this 2 is cancelled, so it'll be x times this entire thing. Minus sign remains, minus x times x squared minus 4 the whole power minus 3 by 2. I hope this much is clear. Minus 3 by 2. You're just writing them as it is. Now let's simplify this over here. This minus x plus x cancels off. So what happens here? Minus 2 and minus 1 is minus 3 divided by, now let's multiply this inside, FOIL rule. X times x is x squared. X times minus 2 is minus 2x. 1 times x is plus x. And lastly we have minus x. Minus 2, sorry. Divided by, what remains here? Here we have, okay, we will not write that over there because there is a rule. See, now imagine you have a divided by b, this whole thing divided by x. What happens here? This is equal to a by b multiplied by x, right? So I can write it out over here itself. See, this term multiplied by this entire thing. What is it? Minus x times x squared minus 4 the whole power 3 by 2. This is it. They're all multiplied, okay, to each other. So that is mainly it. Sorry, let me just remove that closing bracket over here. This one is multiplied with this term, and but this power is minus, so they're all in the denominator here. Only 3 is up. But here if you look carefully, what is this minus 3? So if I have x power minus, say, 3 by 2, over here it's already 1 divided by any number divided by, this is equal to x power 3 by 2 in the numerator. I can take any power up, but the sign changes. So what I would do over here is minus 3. Now 1 minute, do we need this minus? No, minus and minus sign cancels off, so I'll remove that minus off. Okay, now here then let me write it out. See, there is x term which I need to multiply throughout, but that I'll do in the next step. It'll be too much at once. 3 multiplied by x squared minus 4 the whole power minus 3 by, sorry, it will become plus 3 by 2. Why? Because I took it up. Divided by x squared minus 2x plus x is minus x minus 2. Multiply all this by x. What happens? This will be equivalent to 3 into x squared. Now if you multiply this power inside, what happens? You don't need to multiply. I'll just leave it. I'll just tell you in a minute. It's 3 by 2 here. Divided by x power 3 minus x squared minus 2x. So this is the simplified answer. But here, Are the degrees same? The highest degree over here is 3. Now you don't need to apply the rule a minus b the whole square. No need of any rule. Just multiply these two powers and see what happens. 3 by 2 is how much? Multiplied by 2, it will be 3. So it will be x power 3. The highest degree in this term can only be x power 3, nothing else. And it's a single term. When you multiply 3 inside, it will be 3x power 3. So we are not going to solve it all. Just reason it out. Your highest degree over here will be 3x power 3 and the denominator is x. Why are we writing this? Because we know over here everywhere we have limit x tends to infinity. We have not written, I have not written it, but you need to write it over here. It's x infinity. This is, I don't have proper space, so I've written it, horizontally as well, but better to write vertically, and limit is always there. Here also we have this limit x tends to infinity. Now, when we know this rule, I've already mentioned it before. When you have coefficients of the same degree, this down term is x power 3. This and this is same, right? What is the limit? Whenever you apply infinity, these go off. The answer is 3. So the limit over here for infinity is 3. So this entire thing over here, when we solve it up, is 3. So this is a very important, but now we are still not done. There is a small step remaining. What is this 3? That is equal to ln y is equal to 3. I told you y will be the final answer, that is e to the power 3. To remove ln, just take exponential. So this is the answer. E to the power 3 is the final answer. So let me show it in calculator as well. So now let's put this entire question in the calculator. I think I moved ahead. This was the question. So here, just type it out without that, you don't need to put the absolute value. It's x plus 1 divided by x minus 2 to the power, we have square root x squared minus 4, and take the limit that is calculated at 999. You get 20.08 and so on. Why? Because e to the power 3 is same thing, 28.08, and it goes on. So that is why this is the correct answer. I hope that is clear. So the final answer is so on. You need to do all the methods, and that is the thing. It's a bit lengthy one. Now let's look at this problem here. Now this one, as you can see, there's no power, so it won't be like the same previous problem. There is no ln y. Let's just apply the limits and see what happens. Over here, when it's 1 divided by 0, it's going to be infinity. Minus, what happens here to the right side? It'll be 0 divided by 1. So it's 0 here. Is this indeterminate form? No, not indeterminate form. So here we are not going to use L'Hopital's rule. We will just do basic algebra and try to simplify this. How could you simplify? So I can see that, let me try taking common terms. This can be written, this entire term, limit as x tends to 0 from the positive side, 1 by square root x minus square root x divided by square root x plus 1. This is the way to simplify it. And now let me take the common term. How do we do that? You multiply this denominator up and down here and this denominator up and down. Let me just show you over here. Whatever is this denominator, square root x plus 1, here also square root x plus 1. This is square root x, square root x. Now if you see, the denominators match. Here the denominator is what? Square root x and square root x plus 1. And above will be square root x plus 1. What about this? Minus, again, square root x and square root x plus 1. Or you can write this first, it's up to you. And here square root x and square root x will be 2 times square root x. It's x, but I'll just write this. Now let's simplify. The denominators are same. Square root x multiplied by square root x minus x plus 1. And what happens over here in the numerator? It is square root x plus 1 minus x. Now here, can we apply the limit? Everywhere you should write the limits, guys, at the left side. Let me just try applying the limit. Here it'll be 0 plus 1. It's 1 minus 0. It's 1 divided by something. It's 1 divided by 0. Yes, we can apply the limits. Let's apply limits. Applying limits. You can directly apply the limits. You do not need to write as well. It'll be 0 plus 1 square root minus 0 divided by 0 multiplied by 0 plus 1. Here it's going to be 1 minus 0 divided by 0 times square root anything. 0 multiplied by 0 is 0, so it's 1 by 0. What is 1 by 0? It's infinity. So the answer is infinity, the limit. You can just try this in the calculator. Put this entirely in the calculator. Take the limit of 0.0001. Calculate the value. You will get infinity, a big number. That's it. So here, answer is infinity. But you need to do the steps. Only 2 steps are done. But these are the exact steps, okay? Now we'll go to another problem. This one is also same, easier. Why? Because if you don't have power, it's easier. But I highly feel that, the power problems might be asked in the exam. That's why please study them thoroughly. Now here, what do we do is, let me first apply the limits and check. If I apply the limits, it's going to be square root 4 minus 2 divided by square root 9 minus 3. It's going to be 2 minus 2 divided by 3 minus, oh, it's 0 by 0. This is indeterminate form. I can but apply L'Hopital's rule. Why? Because it's 0 by 0 in this form we can apply easily. So let me derive the above term and below term. This seems to be a very easy problem because they have directly handed you 0 by 0, which is a easy L'Hopital's rule. Square root is 1 by 2 root x is square root 5 minus x. Multiply. Okay, now this is the derivation of square root x. D by dx of square root x is 1 by 2 root x. But here, it's not just x. There is 5 minus x as well. What is the derivation of 5 minus x? It will be minus 1. And minus 2 will be 0. Divided by, again, 1 by 2 square root 10 minus x minus 1. I hope this is all clear. And now what else do we have? After this, let us just rearrange it. This minus 1 and minus 1 cancels. The negative becomes positive itself. Limit x tends to 1. Let me just rearrange and write. See, imagine you have 1 by a divided by 1 by b. What happens? This becomes b by a, because 1 by a remains, and this term will be b divided by 1 multiplied to it, so b by a. So I'll write this above. It's and 2 cancels, okay? So I'll just simplify and write square root 10 minus x divided by square root 5 minus x. Why? Because this is the form. And now then when I apply the limit, okay, now I can easily apply the limit. When I apply the limit, it's going to be square root 10 minus 1 divided by square root 5 minus 1. That is square root 9 by square root 4. That is 3 by 2. It's 1.2. So the answer is 3 by 2. And yes, that's it. If you apply in calculator, also you should get this. I will show you in the calculator now. Here, all you do is write this given function. That is root 5 minus x. And go out of that square root and minus 2 divided by again square root 10 minus x. And over here go out and it's minus 3. Now calculate 1. Okay, it's an error because we saw it was 0 by 0. So you don't take 1, take 1 point, okay, not over here. Calculate 1.00001. The answer is nearly 1.5. And also we can calculate it in the negative otherwise, not 0.999. Not minus, sorry, it's 0.9999, which must be very close to 1. It's either 0.999 or 1.001. You can see the answer is nearly 3 by 2. 3 by 2 is 1.5. So that is the correct answer. And now we have 1 by x. So here, when I look at it, I know it's in an indeterminate form of power. See, 1 by 0 becomes the whole power 0, right? It'll become infinity to the power 0, which is indeterminate form. But here the thing is, yes, it's an indeterminate form, but can you directly use L'Hopital's rule? No. I have to write that term L and y, because whenever I told you the power is the exponent is the, you have to write it like this. So let me write L and y. Over here I directly write limit, as x tends to 0 positive. I had done few 2-3 steps at the beginning, right? You have to write that over here, but I'm directly writing it because it's just taking ln on both the sides and then applying limit. And over here, when you apply limit x tends to 0, it's the same thing. But here you will have this x comes down, ln 1 by x. I hope this much is clear. Now this can be rewritten limit as x tends to 0 from the positive side, ln 1 by x divided by 1 by x. Now then, let's derive. What is derivation of ln 1 by x? See, ln derivation of 1 by x, that is equal to 1 divided by 1 by x, but we simply write x. I hope this is clear to everyone. Instead of writing 1 divided by 1 by x, sorry, ln x or ln x 1 by x will be x. Just remember that that's the rule, ln x is directly x. So what I do over here is limit as x tends to infinity. Instead of writing ln 1 by x, I'll directly write x multiplied by derivation of 1 by x is minus 1 by x squared. Now divided by, what is derivation of 1 by x? Again, it's minus 1 by x squared. I'm sorry guys, here the limit I wrote infinity, okay? It is 0. See the question, there was 0 from the positive side. This and this cancelled. So what is remaining? Limit of x tending towards 0 from the positive side for x. Apply the limit, it's going to be 0. Do not forget, whatever the answer is there, that is ln equals y. So here it's ln equals y, isn't it? So y will be equal to e to the power 0. What is e to the power 0? Literally anything to the power 0 is 1. Other than infinity to the power 0, it's undefined, indeterminate. But otherwise, it's 1. Any number here. So the answer is 1. Simple as that. If you just put in the calculator and solve it at 0.00, and then you will get 1 as well. So that is the correct answer. And now we will move to another problem. Again, it is similar. No, is it similar? It might be a little different. Anyways, let's solve it up. So first, apply 0 and try to see what is happening here. So let me apply this as cosine 0. And then over here, 1 divided by 0. What is this? 1 divided by 0. What is cosine divided by 0? If you recall, sine 0 is 0, cosine 0 is 1. So it's 1 to the power infinity. 1 by 0 is infinity. So this is indeterminate form again. So now can we use L'Hopital's rule? Yes. But what happens is, before we apply L'Hopital's rule, we have to get it in terms of infinity by infinity or 0 by 0 in this indeterminate form. So how do we do? Again, whenever the power or exponent is there, what did I tell? You have to take ln y is equal to limit as x tends to 0 from the positive side, 1 by x ln cos x. If you're thinking what just happened, please go back to the previous problem. I think so question 33. Everything is done in detail. Every question will get this form. After you take ln on both the sides, this comes down, and take limit on both the sides, and this much will be the this. After 3 steps, you'll get this. Now let us start solving. This is 1 by x here. Can I just write it as ln? Look over here. Now you have directly 1 by x. So I'll write ln cosine x divided by x. Don't need to do 1 divided by anything because it's already 1 divided by x. It's in the denominator. Now you can see here I've got the numerator, denominator, and let's now apply 0. If I apply 0 over here, what is it? Cosine 1. Cosine 0 is 1 basically. ln 1 is 0 divided by 0. Why? Natural logarithm of 1 is 0. This is also 0. This is again indeterminate form, and apply L'Hopital's rule here. Why? Because it's in 0, 0. Or if it was infinity, infinity also, you can apply L'Hopital's rule. So now then, I will apply L'Hopital's rule. That means you have to derive the numerator and the denominator. So what do I do is, just let's derive it up. It will be 1 by cosine x. Why? Because natural logarithm x derivative is 1 by x. But over here we have cos x multiplied by derivation of cosine x is minus sine x. divided by, what is the derivation of x? It's just 1. So what is this? What did we get? Limit as x tends to 0 from the positive side, we will have negative. Sine by cos is what? Tan, right? Negative tan x. Now let's apply the limit. What is tan 0? If you just apply the limit over here, you will get minus 0 is 0. I'll directly write it as 0. But this is not the answer. You need to understand this is ln y is equal to 0. So y is equal to, yeah, you just have to take this. Y will be equal to e to the power 0. So this is the final answer. Or what is e to the power 0? It's 1. Anything raised to the power 0 is 1. So this is the final answer. You need to write this up. These are the exact steps. You do not need to write this one over here. Okay, this much, whatever is there to the screen, needs to be written for this particular question. I hope such questions come. They are easy ones. And you can see the answer is 1. Now we will go to the next one. This is a bit difficult, and the last one is really difficult. Now here we have done similar problem. Do you remember the modulus to the power something? That is similar to this itself. Let us solve this up now. First, apply infinity. When we apply infinity, see the degree. This is 1, this is also 1. So what happens? It will be 1. Okay, this cancels. So just 1. Then what is power infinity? Power t is infinity. So this is an indeterminate form. We do not know what is 1 power infinity because 1 is just 1 and infinity is just a large number. It is indeterminate form. But we cannot apply L'Hopital's rule just yet. Why? Because we need to rearrange and write this in either infinity by infinity or 0 by 0 form to apply L'Hopital's rule. Here, whenever you see the power or exponent that is there, we directly jump to the method of natural logarithm y equals limit as t tends to infinity. What happens? This t comes down because that's the natural logarithm property, and we have t minus 3 by t plus 2. If you're thinking why, again, please go back to the question 33 where everything is explained in detail. We are just considering this term to be y, and we are taking natural logarithm on both the sides, which will help us this t power to come down. Now then, this I will write it as limit as t tends to infinity, natural logarithm, let it be ln, on the numerator t minus 3 by t plus 2, divided by, what happens to this t? This t can be written as 1 by t. That is same because 1 divided by anything in the denominator goes up and multiplies, right? It's the same thing. Now this is 1 by t. Now let's apply infinity and check. If I apply infinity, it will be ln 1. ln 1 is 0, so this above term is 0 divided by 1 by infinity is 0. It is indeterminate form. Apply L'Hopital's rule. Okay, now we can use L'Hopital's rule. What is L'Hopital's rule? You have to derive this. We have done this similar problem before. So let us derive limit as time t tends to infinity. They will not mention its time or anything. Now, derivation of this, you're just inverse these two. T plus 2 goes up, t minus 3 goes down. Multiply it with this product rule. That is t plus 2 the whole squared. Derivation of the above term is 1 multiplied by t plus 2. See, the rule of a divided by b is a prime b minus ab prime divided by b squared, isn't it? The same thing. We derive the above term, gone, it's 1. And the below term, what happens? We will have just t plus 2 remaining, minus here the above term will remain, t minus 3 will remain, the next term will be 1. And now we can see cancel this and this off, but still the down term is still there. What is 1 by t? It is minus 1 by t squared. This is the derivation of 1 by t. I hope so much is okay. Now once this is 1 over here, negative 1. Now once this is done, what can we simplify here? See, this above term, right, will be t minus and minus will be multiplied inside. It will be t plus 2 minus t plus 3. Why? Because this 3 is minus is multiplied with this minus 3. Now what remains down is t minus 3 and t plus 2 divided by minus 1 by t squared. But I'm not going to write it down. What I'll do is I'll take this above. And you just have to flip this. It'll be t squared by 1. And don't forget the minus sign. That's it. Now let's simplify this. It'll be t and t cancels off. You will have 5. Sorry, 2 plus 3 is 5 minus t squared. Over here it'll be t squared minus 3t plus, sorry, plus 2t. T times t is t squared plus 2t minus 3t here. I'll just rewrite this entire thing. You need to be very careful with this. T times t is t squared. T times 2 is plus 2t minus 3 times t is minus 3t minus 6. And this 1 is 1. And here, now when we simplify this, what happens is minus 5 times t squared divided by t squared minus t minus 6. And now what we do is, okay, that's it. What is the left side limit? Limit is x tends to infinity. Since it's limit of infinity, do we need to do anything further? No, because over here we have same degrees, right? So the limit, when you apply infinity, you will get over here as minus 5. So ln y is equal to minus 5. So what is y? It is e to the power minus 5, and that is the answer here. So just in these steps you get it. I mean, it's not that difficult, only so many steps. So you are, I mean, it's not easy also, but it's not that difficult if you understood the gist of it. If you understood the first problems, then this is, the similar way. So this is how we solve it up. And you can see the answer would be e to the power minus 5. You can also check it in the calculator and you can get the correct answer, same one. But you need to do the steps, so please follow these methods. Whenever you have exponent, it's always this. So let's do the last problem here. Finally, we reach the last problem. Again, let's check whether it's infinity. So over here, what happens when we have limit? What is the coefficient here? It's 1 divided by, what's the coefficient over here? It's 2. Half to the power infinity. Now here, is this indeterminate form? This is not indeterminate form. Okay, this is not an indeterminate form. So we are not going to apply L'Hopital's rule. But still, you have power infinity. We have to do the same step of ln y. This is natural logarithm y. Ln y will be equal to limit as t tends to infinity. What happens? T comes down and you have ln over here multiplied with t minus 3 divided by 2t plus 1. Now here then, this power has come down. But if you rewrite it, now if you apply the limit infinity, what happens? It's half. Ln half is not 0 or 1. You won't get indeterminate form. You can't apply L'Hopital's rule. So we can't derive the above and below term at all. Even if you do, you'll get the wrong answer. So what we do in such cases is, you can recall applying limits. We see the degree, right? What is the highest degree here? It is 1. 1 is the highest degree. So whatever is the t to the power 1, you divide it throughout by that. Let me show you what happens. It is limit as t tends to infinity. Here, let t be as it is. Okay, I'll just write this t as it is. Here, what happens with this? ln t divided by t minus 3 divided by t divided by 2t divided by t plus 1 divided by t. What did I do is just all these terms I divided by t for each term. Now, if I simplify this, what's going to happen? Left side is going to remain the same thing. T tends to infinity, t times ln. Now here it's going to be 1 minus 3 by t divided by, over here it's 2 plus 1 by t. And now we can apply limit of infinity. Let's just apply infinity and infinity. This is a single term. This is one more term. So what happens over here? This is infinity. Let me write it out over here. Infinity, okay? And what happens over here? Multiplied with, this is all multiplied, okay? ln, when I apply infinity, this doesn't affect, 1 remains 1 only. But what happens to this part over here? Minus 3 by 2, minus 3 by t. Whenever you have 1 by t, when t is infinity in the denominator, it's 0. So 1 minus 0 divided by 2. 1 by infinity will be again plus 0. Okay, so this is why we did it. Now infinity will be equal to what? Ln half. Okay, this is the thing. What is ln half? Now let's take our calculators and solve. Now here there are two ways. One is direct calculator method. What is ln half? Ln of half will be, it's negative some number. So any number multiplied by infinity will be infinity, but it becomes minus because this is minus, isn't it? So it will, the answer is minus infinity. That is one way. That is the easier way, I can say. It will be directly infinity times minus some number, okay? Minus um, uh, 0.69 or something. So it will be minus infinity. But there is another way to do this. I will show you now what that means. Here ln half is there. What is this? It is ln1 minus ln2. Why? Because the above term is 1 minus this denominator. That's the rule, right? If you have ln a by b, that is ln a minus ln b. Numerator will be first minus the denominator. Now in such cases, what is ln1? 0 minus ln2. So negative sign. Whatever answer is there doesn't matter. It's 0.69. Yes, it's 69 here also. But minus sign will remain. When you multiply this with infinity, it will be minus infinity. That is another way to understand. But the easier one would be just put this in the calculator. You got this minus, so it's minus infinity. But we are not done. Ln y is minus infinity. So what is y? E to the power negative infinity. Now, what does negative infinity mean? It goes where? Now, how would you graph exponential function? If you see the graph of exponential function, it's like this, right? What happens when x is infinity, when it's a big number? You can do it in calculator, but I just want you to easily understand this. When we are in minus infinity, y is 0 over here. This e to the power minus infinity is 0. So its answer is 0. The limit over here is 0 basically. Let me show you in calculator. E to the power, just do e to the power minus x. And let's take x as, calculate x at big number. It's 0. Okay, so that's the thing. Or you can just put this entire thing in the calculator. Let's do it. X minus 3, that's minus 3 here, divided by 2 times x plus 1 to the power x. Now calculate it at what? Infinity is a big number. What is the answer? It's 0. That's how we can solve it. But the only difference is you do not need to write all this. The only main thing over here, what is it? It is not indeterminate form. You cannot use L'Hopital's rule. You have to apply the normal method, just by dividing by the highest degree. So you need to see whether it is an indeterminate form or no. That is the most important thing. And then you apply L'Hopital's rule. Whereas in the previous problem, we applied L'Hopital's rule. We derived above and below. But here, no. We're not deriving above terms. We're just, dividing by the, highest degree power term. And then we are just sorting out by applying limits. And easily we got the answer minus infinity. With this over here minus infinity, but e to the power minus infinity is 0. That's how we solve it. So that is how we solve all these problems. They have done some other method, but I would suggest you to go with this method. It's easy to understand. And now this method, right, will work in any problem, what I've just told you. If it's indeterminate form, L'Hopital's rule. Otherwise, just this method. Every time it will work. That is the end of all the writing part questions. If you have found these videos helpful, please share it with your friends. Let them know about this channel, Best Math, where you can find all the end of term exam questions and exam lessons explanation for free. And I just want to thank all the students who like my videos, who share my videos, and all the gratitude comments. I really thank you so much. Your comments really make my day. A single thank you always puts a big smile on my face. Thank you very much. And I wish you all the best in your exams. I hope everyone does well. If you have any doubts, any clarifications, please do post them in the comments and I will get back to you.